Okay, I went to more and actions, start recording. It says recording has started, so I guess we'll see if this works. Let people in the meeting know they're being recorded. So I guess I'm letting you guys know right now you're being recorded. Is that okay?
Yep. I appreciate it.
Yep. Okay, so the purpose of this is just to give you guys a quick familiarization with what's going on. We've got a lot in the pipeline going back and forth with the engineer right now, just basically on, like how the building's operating, what we're seeing as we discover the personality of the building. And by that, I mean, let me go to the chill water system here. And can you guys see me moving the cursor around? Or can you guys see the screen with the chill water plant?
We can see the screen with the chill water plant. I'm not seeing your, okay, there, yep, we see your cursor. It's very small from what we're seeing here, but we can see it. So we may have to ask you to tell us, upper right, lower left.
Okay.
Does that
Gotcha.
help?
Okay, so on the upper right, you can see the different loop pressure sensors for the chill water system. And so you have sector AB chill water differential pressure right now is running 50.3 pounds. So we have a bunch of questions like going back to engineering saying, hey, we're running 50 pounds in all these sectors. And it's the result of having to run sector H at a minimum of 20 pounds right now. So you can see that 20-pound PSI differential pressure set point is the minimum we're controlling to. Now, sector H is the first one to get hot, and it's the one we control to because it's the furthest one away from the plant. So we have to pump according to that pressure sensor. There are no pressure regulating valves. There's nothing else. It's just you got a big campus with a chill water system, and H, the minimum we can go is 20 pounds on that set point. Otherwise, we lose the building.
So in order to, let me paraphrase that, make sure I'm on the understanding the right thing. In order to get 20 pounds all the way out at H, it takes 50 pounds at a lot of the other zones that are closer to the pump system. Is that correct?
Correct. It doesn't take, it's making 50 pounds. So,
okay.
And just a little backstory, a job this big and this complicated, as we learn the personality of the building, meaning now we have students in there, we have teachers in there, we actually have live heating and cooling loads that we see fluctuate every 45 minutes to an hour. We see when the kids are leaving the rooms, we see when they're entering the rooms, we see the CO2 levels going up and down, and we're trying to go through this tremendous amount of data and tune loops individually for different classrooms. So with that being said, we still have a lot going on. Commissioning is already started, and they're going through a bunch of stuff. And then they're asking for things that we weren't asked to do in the project scope. So we're trying to get aligned with SCC and then the project engineer and try and customize the stuff for what they're asking for. So there's a lot of stuff still in progress. There's a lot of temperature complaints every day. The temperature complaints are because that, the cooling set points are what we agreed to, 73.5 degrees. And you have teachers that get unhinged because their room is 73.8. The chill water valve's 41% open, and you're 0.3 of a degree above set point. God bless you guys, because I know you guys deal with that all the time, but I don't know, Kevin, is 73.5, like that was a buffer because the contract wasn't it like they need to maintain 75 degrees in the room?
Yeah, we typically peak out at 74. I think in the contract we can go to 75. But so 73 or 73 and a half, if that's as high as we're going, that's well within the district standards in the contract.
Okay. So just as a random example, I'm switching from the chill water plant over to the fan coils supported by DOAS 1. And you can see that we've got all but maybe a couple here, 73.4, where we lowered it a tenth of the degree because the teachers were complaining. And it's like we literally went a tenth of a degree and they stopped complaining. So I'm sure that's something you normally deal with, but it's more of a placebo than anything. But you can see it's 8 o'clock in the morning, 8:18, and we got a couple rooms that are already starting to warm up. They're right at set point. Chill water valves starting to crack open. Some of the rooms that are on the southwest side, I've made the algorithms a little more aggressive, so the valves open a little bit faster. Obviously, because when it's sunny out, you got 3 stories of glass and brick, and it heats up very fast. And we see that in G and H. So a lot of the fan coil algorithms are more aggressive in those 2 sections of the building than, let's say, D or A and B.
So can we talk a little bit about that? Because that right there is really helpful information. That's the kind of information that you just wouldn't know 5 years from now. When you say the algorithm is running more aggressive, you're talking about more or less the PID loop tuning for the zone control. Is that a fair statement?
Yes, the proportional, integral, and derivative. Obviously, we don't use derivative and HVAC control, but the proportional gain is significantly set faster in G and H.
Okay, and that's done. And what type of mechanical devices is that being done on? Are these, I think you said fan coils?
Yes.
Okay, so can you, just because we're not very familiar, oh, perfect. Yeah, we're just not familiar with this site. There's been so much construction going on. So it looks like this is what you're saying. This is our fan coil unit. It looks like we have cooling capabilities, heating capabilities, and a fan. Each one of these units, this FCU 1201, I'm assuming serves a classroom. Is that a fair statement?
Yes, and you can identify the classroom number toward the top of the screen here. I've got a tag. It says room number 228.
Awesome. Awesome. Thank you.
So you'll also note to the left here on the top, it's also the fan coil is served fresh air from VAV 1201. So I just put a little tag here just as a reference. And every one of these fan coils, as you can see, this name here in the middle, fan coil 1201, is directly served by a subordinate variable air volume controller, also named 1201. So they go hand in hand. And with this system, I don't know, do you guys have other buildings that are fan coil heating, cooling primary, and then a DOAS CO2 demand control ventilation setup like this? Or is this the first building you guys have done like this?
This is the first I'm aware of. Now, I'm not familiar with Y East, but I'm not familiar with with this layout. So you're saying let's take this as a classroom. Room 228 has a VAV box up in the ceiling, and that's from our DOAS unit providing minimum outside air, and it's at the variable volume. And then also above the ceiling, there's going to be a fan coil unit that provides more of the zone's specific temperature control. Is that a fair assessment of what you're telling us?
Yes.
Okay.
And I'm gonna put this in edit mode real quick, and I'm gonna move this so you can see it.
So from a temperature standpoint, how does that, from like a sequence of operations standpoint, how's their relationship for controlling temperature in a zone? Because obviously your FTU has heating and cooling capabilities, and I'm assuming the cooling is DX, or is that, no, that's chilled water, right?
Chilled water. Yep.
And then the heating is boiler water.
Correct.
Okay, and then the VAV, so both of them, the VAV does have some influence on temperature. Does the VAV, I guess I'm not familiar with DOAS through VAVs with another temperature control source like that. Can you help us understand how their relationship is between the VAV and the FTU for
Yep.
maintaining temperature?
So I moved these data boxes out of the way. I put this in edit mode for the floor plan, and we're looking at the second floor plan for second floor G. And so room 228 was the fan coil 1201 we were speaking of. So I slid these up out of the way, and you can see that there's a fan coil in the room that feeds air to the room. The fan coil does all the heating, cooling, and determines whether or not it needs demand control ventilation, meaning the CO2 level is too high. All the VAV does is bring in fresh air. It doesn't have anything to do with heating or cooling. It doesn't care about heating or cooling.
Okay.
If the fan coil says, hey, my CO2 level locally on this combo sensor is above set point, which BlueMac gave us a standard set point of basically 600 parts per million. They wanted it to just be 200 parts per million higher than the standard outside air CO2 level, which is generally 400 for Portland.
And are we monitoring the outside CO so we can have a firm differential, or is it just based off of the average that we know it to be?
It's just based off of the local area average.
Okay.
I mean, obviously, forest fire is going to change that. There's other things, but the typical for the Pacific Northwest is 400 parts per million if you're just standing outside.
Uh-huh.
So 600 is the set point that they want us to start opening that VAV box at and go to a ventilation flow set point. So if you go above that 600 parts per million, the DOAS unit is constantly monitoring all of the move this back down. The DOAS unit is constantly monitoring all of the VAV controllers that are out there, and it's looking at a static pressure set point. So why I'm talking about that, let's go look at DOAS 1 real quick, and I'll paint the picture a little bit bigger, broader here. So we have a DOAS unit with a heat wheel. There's no heating or cooling coils in this DOAS unit. It is just sucking straight outside air. So the only heating or cooling that you guys have is just a little fan coil in each one of the rooms. Now, those fan coils are all oversized and they have a ton of capacity. So heating or cooling the room should never be a problem. What the engineer did was he oversized them and then turned the fan speeds way down on them. So you have three types of fan coils. You have fan coils that have ECM motors. You have fan coils that have VFDs. And then you have 3-speed fan coils, meaning there's no modulation other than low, medium, high. Okay. Now, depending on the mode of the fan coil, if the fan coil is calling for cooling, we were given a cooling fan speed we had to maintain. The balancer went through, balanced all the ductwork, measured the total airflow coming out of the fan coil, how much chill water was going through the chill water coil, and then gave us the speed that was initially determined by the engineer. So those high, medium, and low speeds we put in for cooling, heating, and whenever the unit was satisfied. If it was in between set point, it would just go to a ventilation speed. The ventilation speed we'll talk about later. It's just a very low speed that just keeps air circulating through the room. And a lot of the initial complaints that we got from the teachers are they're calling all the time, complaining, saying, my unit's not working, it's not running. And we look at the room and it's within set point, between heating and cooling set point. Room temperature's fine. The fan is at the minimum speed, which is 10%. And they can't hear it running, so they get all anxious, and then they put in these calls saying, my unit's not running, it's broke. I want somebody to fix it before it gets too hot in here. Well, it's just in ventilation mode, and they're ultra quiet. You guys have, I think you guys bought $1 million sound deadening package that is on all this equipment. There's all kinds of stuff they did to this stuff to make it super quiet. So that's like good and bad, right? And
Right.
once the teachers and staff, get familiar with the building and, they're coming from a building that wasn't this efficient, and they expect to hear this loud, roaring noise. And if they don't hear it, there's a problem, right? So I think the initial shock, we're hopefully on the back end of that. We still get some complaints here and there about like, I don't hear it running, but it's not that it's not running. It's just in ventilation mode because the space is satisfied, the CO2 level is good, and it backed the fan way down.
And just to make sure that we're on the same page, the fan that you're talking about that backed way down, because you were saying the fan coil unit has, it can be it sound like an EMC motor, a VFD driven motor, or a 3-speed. So those are the fans you're talking about that when we're just in ventilation mode, where we're successfully maintaining temperature between set points. That is the fan coil unit fan that you're talking about that will ramp to the lowest level, not the VAV, correct?
Correct.
Okay, perfect. Thank you.
So going back to the fan coil, there's 3 actual speeds, and you know, now that I'm thinking about that, I think what I'm going to do, Kevin, is I'm going under the set points column in the middle here. I'm going to, oh man, let's talk about this for a second, because this is, how do you guys want to use this building, right? Like I want to make it so it works for you guys. So you've got those 3 speeds. Do you want them displayed under the set points, or maybe under the overrides down here? So if you do have a problem and you do want to override, we probably shouldn't override the 3 set speeds. And what I originally went to is I just gave you a manual fan speed override. Like you probably don't want to mess with what the engineer designed as far as the min, max, and ventilation speed, right?
Right.
So I think that's why I ended up going with I made the actual fan speed overrideable. So if you did want to do maintenance, or if let's say you had a teacher that just wanted more airflow in there,
Right.
you could override it from here and do that.
For troubleshooting or specific use. And as far as what condition it's in, you could even put that up in the status to tell the operator, hey, this is what condition it's in, so that it makes sense to what they're seeing. But I would suggest, and we can do it all in one meeting if you want, to make sure that SCC and Collins, that we're all on the same page. The last thing I want to do is say, yeah, we want this, and then there's some contractual reason why we shouldn't have, and I don't want to waste your time. So if we can have that information on there, we'd love it. It could be even up in the status if you want, especially if it's going to be adjustable.
Yeah, here's my thing. I think if anything, I'll put it on the set points. It's not that big of a deal for me to do. And honestly, who cares what they want? They're not going to be operating this building 10 years from now. You know what I mean? What do you want? Like, it's not going to cost me any extra money. It's going to, these graphics are relativized. So if I change it to 1, there's only 3 that I have to do per floor. You know what I mean? So I'm talking like 30 minutes worth of work for me.
Is it something that we can adjust?
Well,
because if we
shouldn't make it adjustable, but we should just show what high, medium, and low speed are. So when you see it's at 32%, oh, I'm in cooling fan speed,
So can we put that in status then? Because the way I interpret it is status is something that we can't change, but it's information to tell us what condition it's in. And it seems like that would be a better place to put it. Can we fit it in that blank spot up there in status?
If that's what you prefer, yeah. I can move these 2 bars up and make some more room, because it's going to take quite a bit more room. That's why I was thinking about putting under like fan speed, set point, heat, cool, ventilation, but I can do it on our status as well.
Yeah, anything down in that set point section, we should be able to override. We should be able to change, and so it'll get confusing. If we can put it in the status section, then the operator knows that they can't change it, at least with right there at that point, but it's information to show them the status of the different functionalities. So status would be the best for us.
Okay, I'm going to do that for you then, and then I'll let SCC know that's what I wanted to do to make it a little more user friendly.
Perfect.
And then other than that, you have your standard overrides like you do in your other buildings that you're familiar with, and then your alarms. So you got a high zone alarm, low zone alarm, and you've got your fan command on off, your speed, your hot water, your chill water valve, whatnot. You've got all your temperature logs, your room set points, OC, on-OC. You've got your alarm set points that you guys can adjust. Well, you can override or put them back to auto. The spec said 5 degrees above and 5 degrees below. So that's what we did. And then we just made it so, let's say you wanted to do something in a room and instead of 78, you want it at 77, just obviously do your override or your timed override for however long you want to test it. Or maybe you just got a customer that just is not comfortable at 73.5 and you just need to make that person happy and, override the set point or set the set point a little bit, cooler and then override your alarm limit. But anyway, it's just about as customizable as you can make it. You have your morning warm up set points, your morning warm up discharge air set point for the unit, your night high limit, night low limit, pretty standard from what you guys are familiar with your other buildings, for just a generic fan coil or air handler.
Can I ask a quick question? We've got a question on our side. So you're going to put the status up there of what of the 3 speeds it's in, just kind of more of a modes of operation things. But yet down in the override is where you have supply fan speed. So if we wanted to change the speed of that FCU, let's say they complained about noise, but it happened when we weren't there, we can ramp it up and slow it down right there, correct?
Yes.
Okay,
right.
Perfect.
Now, if in the future
that answer it, Randy?
You decide that 32% fan speed for cooling is just not cutting it and you want to customize it for 37%, you know what I mean? I would recommend only having you do it. Go through Workbench, you find the fan coil, you launch the program, right? This one's actually 202, so it's F. So you go to F 202. And since we're talking about fan coils, let's just take a quick deep dive here real quick. We don't have to spend too much time on this, but it is something I like to go through.
And when you say launch, are you launching that in GFX?
Yes.
Okay. So is it fair to say I wouldn't need Workbench on my computer as long as I have access to the directories? I just need to be able to get down to the file and then I would launch that Distech file in GFX.
Yeah, I mean, you would just use your server.
Mm-hmm.
Like if you were, let's say you TeamViewered into your server, or if you had Workbench on your computer and connected locally to this IP address, then you would open the directory and just find the device, launch the wizard, and that will open GFX locally on your computer, which would look like this.
Mm-hmm.
And then you would go to your fan speed control tab. And let's say you wanted to make that permanent change from 32% to 37%. You would just change it right here to 37 and then click synchronize. And that would hard code it. So when the controller cycled power, it would come back at 37% for your max fan speed.
And is it fair to say that right now, because these are, I'm assuming, from the engineering team, that everywhere in the building, they are the consistent, whatever you had said, 32% or 32 or whatever, on all of them. None of them have been tweaked like you're showing for individual reasons.
Yeah, everything is set right now per what the design standard was.
Excellent.
Other than the minimum speeds, because like some of the min speeds were 3%. And so I went to the balancer and I said, well, where did you guys come up with that 3%? Is that a calculation? Is that a, did you actually override the fan to 3% and then you read your registers and that's what you needed for the just, pure ventilation mode? And they're like, yes. And I'm like, okay, well, I'm running the fan at 3%. My fan status is in alarm and the fan motor is not even turning. So I've had that argument back with the engineers. I've called the actual equipment manufacturers. I'm like, hey, how low can I actually run this fan motor? And you know, the response I get is, oh, it's an ECM. You can run at 1%. I'm like, okay, well, I'm running at 1% and the motor is not turning. So I can't imagine that's doing any favors for the windings in your motor.
Yep.
Well, yeah, it should work. I'm like, no, no, no. It should work or it does work at 1%. And, you know, you and I both know, going back and forth with the people that make these products, you know, we know the reality of it, right?
Yep.
So
Your fan's got to turn to cool the windings.
yep. So my personal experience, and it is what it is, take it for a grain of salt, but what I have actually seen in the field in the last 5 years dealing with ECM motors, from train units to York units to carrier units to you name it, Daikin, doesn't matter,
Lennox.
that
Yeah.
we have seen on brand new jobs a massive amount of fan failures with ECM motors. And depending on the manufacturer and the style of the motor, whether it's GBM, Pabst, or whoever they're buying the motor from, you can get up a 28 to 50 page troubleshooting guide for the motor module. And that's if the module's built-in exterior on the motor body itself, or if you have to just replace the entire motor like a GBM Pabst motor. There is no module to replace. You buy a $2,000 motor. So all these jobs we've been doing for the last 5 years, oh yeah, we can, you know, on paper it says we can run this down to 1%, 3%. Well, we do that and the motor doesn't actually turn. We do that, the CT won't even read that low. There aren't any manufacturers out there that make a current transducer or current switch that reads below 0.25 amps.
And that was
So-
going to be one of my questions. I'm assuming you're not getting feedback through the ECM motor or the package equipment. You're getting feedback through a CS, I'm assuming, correct?
Yes, yes. So we had to go with special current switches that read ECM motors. And those are better than a normal current switch, you know, go, no go, or adjustable VFD current switch. But there's challenges with those as well when you're running these super low motor speeds. So we had just spent an egregious amount of time going back and tuning these current switches, trying to dial them in. I can't even tell you how much time it's been. And so I went back to the engineer and everybody else. I'm like, hey, don't ever design a project like this again and not use anything other than a current transducer where you actually read the amps. I don't care if it's 0.8 amps. Don't let them do this to your buildings again, right? You want a current transducer, because if that motor can and actually does turn that slow of a speed, you want to see the actual amp draw, not have the current switch guesstimate where the on and off toggle is based on the amp draw. You know what I mean? So remember when current switches came out and originally, you know, you could read the actual amps, and then they just went to go no goes. And then they went to a VFD current switch that had a button on it, and you would set the VFD in 10% speed increments from 0 to 100 and keep pushing the button every time you get to 10. So it would learn the actual amperage of the motor. You go up and then you go back down. These ECMs are a different animal, and there's a lot of different manufacturers that are in a race right now to build a product that will actually work with these motors. So we keep hearing other things coming out that are on the way, but on all these fan coils, you have electronic commutated motors, current switches. So we have set all the minimum fan speeds at 10%. And the majority of them work very reliably and good at 10%. Now you have some units where you have multiple motors. You have like a little mini fan wall in these fan coils. You'll have 2 supply fan motors. And they're hit and miss throughout the building. And it just depends on the size of the fan coil. There's only one current signal and there's only one status. And it's super hard to monitor.
So it sounds like a little plug fan wall in a fan coil unit. So there's 2 parallel fans in a fan coil unit, right?
Yep.
And then are we only monitoring one motor? when you say that we got one status, or is it fair to say if either status goes?
No,
uh,
it's you're monitoring the fan wall when there's multiple motors.
So in my mind goes, questions series or parallel. If one motor is not doing work, does the status go off? Does it take both ECMs to be true to make the status true, or does either one true make the status true?
From what we're seeing, it takes both to make the status true.
Okay, perfect. That's helpful for us. So at least we still have a mechanical flag.
Right.
Okay.
So to wrap up the fan coil without going too far into the weeds, you have your heating and cooling algorithms, and I labeled everything in these programs that you upload it. Here's your algorithm for your CO2 control. Here's your reference hub that feeds this logic from this algorithm into the rest of the control. Here's the determination of your effective modes that the units are in, the occupancy override that happens within the EC SmartView comm sensor. And then, so there's logic in here that looks at some local variables for the awk override. And then it fires this logic down here with your override timer. And right now we have these all at 60 minutes, like we talked about in the meeting. And then I'm going to have a global override button somewhere, probably on the main homepage, that just like we talked about, the spec said 60-minute, 1 hour, occupied override. But if you guys wanted to change that in the future, it'll just be 1 point you toggle. And, if 2 hours is more effective for how they use the building, then you just change 1 point and it'll send it to all the other subordinate fan coil push button override times. Here's your set points page. You obviously know how to use the software. You click the start button and it'll start loading live data. Your comm sensor, CO2, space temp, and then here's your hardware inputs and outputs. And all the programs that I wrote, you'll see that I tagged the top. So like, oh yeah, this is my hardware input output page. Oh, this is my EC SmartView page. Oh, this is the sensors. And actually I should make that say set points, but it's the EC SmartView sensors data that it's collecting. Heating, cooling control, CO2 control, fan speed control, modes. So that way you remember the Schneider Electric stuff you used to have to hunt through with Workplace Tech and all that. And it was just like you upload it and then it just puts it all over your screen. And then you're tracing, you're trying to find all your links, and it was like almost impossible to deal with. That's what we try and avoid with these. Let's see. If you happen to go across and hit one of these X's like I did, like I accidentally was trying to click on a tab and whoops, oh man, I wiped it out, it's gone. All you're doing is just removing it from this page, and you go to the Project Explorer and you double click it and it adds it back to the view. Or if you were just to close it out and then launch the wizard again, they'd all pop back up. So if you're ever doing that, like clicking between tabs and accidentally click it, oops, I just killed the fan speed modes. You go down to Project Explorer, so it shows it all. Double click fan speed control and puts it back.
Now the Project Explorer directory or side, is that always up on the right hand side, or can that be closed and have to be reopened somehow?
No, you can close it, and it's just basically like the properties and the view mode that you have on your local computer when you launch ECGFX.
Okay.
So like if you go to your main header, like let's say I close it here, I can click properties and it'll reopen the properties. I can click Project Explorer and then it reopens Project Explorer. And the menu tab shows up down here on the bottom right. So it's just as simple as, you're not breaking anything. If you hit the X, you close it out and just go back up here to select your view. And it puts it back for you. On some more of the advanced training we'll do later on, have you done any of the stuff with using the resource viewer, hardware IOs? Like if you have a wireless sensor you've attached to it, or if you want to see the BACnet properties that Niagara's looking at, or let's say you want to hunt down an AV or BV, and you know, like maybe sometimes it gets mapped wrong, and you're like, oh, well, Niagara's saying its AV5 is like the unlock heating set point. And then you launch your program, go back into it, and go to your resource viewer, BACnet object. Oh, AV5 is actually the AUK heating set point.
So let's save that for the advanced stuff.
Yeah.
Pretty much all the GFX stuff. And because the guys will be working off of the graphics as a primary. So
Yeah. Well,
but that was good because it showed us the sequence of how those fan coils work, how the logic works, and the sequence of operations, more or less.
Right. And just as a quick overview for the guys, so they have a basic, 10,000 foot view of how this works, is this resource viewer. I have all these AVs, analog values, and they're defined by, they're basically BACnet objects that we pull from the local programmable logic controller that's up in the ceiling that's mounted on your equipment. We take these values and we learn them in Niagara. So for instance, here's the object that I discovered for FanCoil 202. I double click on the points folder, I do a discover, and then I read all those analog values, Boolean values, enumerated values, and they all get discovered and pulled up into your building controller. Then I take all these points from your building controller and I add them and start building a database. And then within this database, I start adding alarm extensions, history extensions. For example, here's a sensor fault extension in Niagara. So when you see all this stuff come up, it's all these little things that get added to each one of these individual points that we pull in for the controller itself. And then that data gets pushed and mapped to a PX page. And PX basically stands for Presentation XML. And it's how you view this through a web browser. So that might be a little bit into the weeds, but essentially that's kind of how it comes together. Now, when you're looking at this in the web browser, I tried to make it as user-friendly as possible. And I would have loved to have made a hyperlink that goes right to the VAV that serves this fan coil. But there isn't currently a way to do that in Niagara when you relativize a graphic. So when this graphic gets relativized, you can see that the slot path, the Niagara calls it an ORD, it's an object resolution descriptor. It provides this slot path that goes into the database and looks for a point folder called points. And then it looks to see if there's a point called chilled water valve position. If there is, it will display that data on the screen. So what relativization helps us do is it helps us keep the database as small as possible. So that means I don't have to make an individual PX presentation XML page for every one of these devices in your building. And as I start expanding these, you can only imagine how much CPU, how much data, how much resources I would have to add by building an individual page for every one of these. So the guy that designed this Niagara architecture, he made relativization to make this more efficient and make the database more reactive.
Jason, can I ask a question on that? So for terminology's sake, when you say you relativized the PX page or the graphics, is it fair to say from a layman's point of view that you're doing what Allerton's always called templates, right?
Correct.
You build a graphic template and then it populates based off of the points list for everything. So it's like one basic graphic that's shared between a bunch of things, and it only populates the points that that particular controller has or has been mapped out, but it's sharing the general graphics like a template. So you only have to generate that graphics once, and share amongst all common equipment. Is that a fair layman's way of putting that?
Yes, that's correct.
Okay, perfect. Because we've always used templates as a statement, and now relativized and template is similar to us from a layman's standpoint, correct?
Yeah, it's just
Okay.
the terminal, the nomenclature that Niagara 4 uses is relativized ORDs,
Mhm.
relativized object resolution descriptors. So yeah, between the different software manufacturers, basically, yeah, it's a template. So
And an ORD is more or less kind of a point.
yeah, a pointer to a point.
Perfect.
And then, if you have anybody that's familiar with the earlier versions of Niagara, it was, previously called a SWID, system-wide identification point. It's so different styles, different manufacturers, different firmwares. I guess the marketing people have to keep changing it, but ultimately it comes down to a Java class path. All this crap that you're looking at is built in Java behind the scenes. Java serves all this stuff up. So again, that might be just a little too far into the weeds, but more for your information.
Perfect.
So with that being said, I put the tag on here so it would remind you that VAV 202 is serving Fancoil 202. If you want to see more pertinent data for VAV 202, you go here to your bottom right, VAV summary. Click on your hyperlink for your VAV summary. And I'm going to click this, see this little spider web up here? This is the Workbench engineering tool that I'm using to look at this with. And all this stuff is displaying in Java right now, okay? It's using JavaScript to show me this pretend web page here. So by clicking this little spider web, it creates a web browser preview. And all this stuff in Java gets converted to HTML5 so you can look at it on Google Chrome or, whatever web browser you want to use, whether it's Opera or Microsoft Edge or, whatever your flavor is. So I'm going to click this little button. It's going to put it in the web preview. So this is what you can see. The format's a little bit different. It's a little bit crisper. It's going to show you what it looks like in HTML5. HTML5, the reason that the internet went to that was because there's bad people out there and they use JavaScript to embed, because it's an active script, and they embed all kinds of malware and crap in it. So HTML5 takes the power of Java and cleans it up and makes it so it's basically not harmful. With that being said, we switched from our Fancoil graphic to our VAV mode, and we were looking at VAV 202 from our Fancoil, right? So you can see we put pertinent data up here: damper position, airflow, effective airflow set point, space CO2. You can see the CO2 load. You can see the CO2 set point. You can see the max airflow set point, min airflow set point. And then I could probably take these off, and I probably definitely should, because you can set them. So these K factors, I'm going to remove these, Kevin, from this table so nobody accidentally messes with these. What I do is I put these on here for SCC. So when they do their tab verification, they can go back and see what the balancer entered for the K factor when he balanced the box, and then what he recorded in his balancing report. So I do this as more of a courtesy for SCC. I could actually make it so it's not adjustable and leave it in there, or I can just remove the column. Is this something that you think you guys need for troubleshooting? I mean, once it's set, it's set. You should never need it again. But like I said, it's just in here as a courtesy to SCC right now until they can get through commissioning.
Yeah, if you could leave that there, that'd be good. Any information we have would be helpful. And I'm not Kevin.
Think about it. Let me know if you guys want it there or not. This is something that gets set once and you never need to set it again. So With that being said, here's all the, obviously the data table. I do have a hyperlink that you can link from this HTML5 table to that VAV box. That VAV box that serves it, that fan coil, you can see that the flow set point is 510. It's making 530 CFM. If we sat here and watched it, we would watch this just kind of dial back down based on the static pressure that the DOAS unit is making right now. So every couple minutes, this is going to readjust. It may go 57.6 because we're within 20 CFM, which is pretty tight.
Jason, I had stepped out for a minute. Did you have a question for us?
Yeah, I was just referring to a table. The K factors I put in here for more so for SCC. Like these are set them and forget them numbers, and I don't know if you want me to leave these in here or not.
No, K factors shouldn't be part of the basic graphics.
Yeah, so I'll take those out. And like I said, they get set once, but I just use them in there as a reference for SCC so they can go back and look at the balancing report and see what the balancer actually put in there for the K factor and if that still is retained in there.
Yeah.
That makes sense?
Yep.
Okay. And then from there, I was just mentioning that you can left click to the actual device itself from that HTML5 table, which will take you to the individual VAV graphic. So it's an extra click from the fan coil, but I kind of wanted to explain why I had to do that with the relativized fan coil graphic. So since there's no way in Niagara to make a hyperlink that goes from a point table in the database as a relativized ORD, you're basically saying, oh, I need to know more about VAV2, 2202. So instead of having the hyperlink here, you're going to go right to the VAV summary, and then you look for 202. So here's 202. I'm going to double click on 202. Boom, that takes me to the relativized VAV graphic. And then from here, we're showing the VAV. Now, the VAV does not have a temp sensor, nor does it have a CO2 sensor. It's getting all this data through your like room temp and CO2 from the master controller, which is the fan coil. The fan coil does all the temperature and CO2 calculations and control. It passes the CO2 level to the box, the VAV box, which then determines the flow set point it needs to match. Now, let's go back and look at the fan coil for a second. SCC has a couple ideas they want me to adjust with this graphic that shows the duct coming from the VAV to the fan coil. So this may change here shortly in the future. That shows, the duct that feeds from the DOAS unit and then the duct that feeds from the VAV unit. Obviously, I only have so much space in here, and there's only so much I can display, but we're trying to work out how we can do that effectively. The main thing is you have a return duct in the room that the fan coil sucks from. And then you're also pushing air from the DOAS into this duct. So what you got to keep in mind is this fan coil fan has to run fast enough to pull the air from the DOAS. So we're saying that if we're in cooling mode, we go to a max flow cooling set point on the VAV to match what we're pulling from this fan coil. So basically the DOAS isn't overpressurizing the room and pushing air out of the return duct of the fan coil. So we're very carefully monitoring what the demands are for the room. And then when the fan coil changes speed, then it signals the demand control ventilation in the variable air volume box to update its flow set point. So the VAV box is always following the fan coil. Does that make sense? Because we don't want the VAV to overpressurize the fan coil. All that VAV for is just to put fresh air into the room, period. It does no heating or cooling control. The fan coil is the one with all the brains, and it's making all the decisions. And that VAV is just a satellite auxiliary fresh air control. It's probably the best way I can describe it. Does that kind of make sense?
Yes.
One of the other things, just going over the fan coils, you can click on the floor plan. It's going to take you to the floor plan. I was just on 1201, I believe. Let me hit the back button. Let me just show you.
Can we ask a question about the zone controls? The question was raised about the sensor, the Distech sensor on the wall. And I say Distech, I know it's not Distech brand now. So it's the sensors that you're looking at, they are temperature and CO. Do they also have an occupancy sensor in them?
They don't have an occupancy sensor, like a PIR sensor. No. But they do have this middle button that you push, and you'll see the screen say bypass.
For the override?
Yes. And what Ty will walk you guys through when you do the walkthrough is he'll show you how the basically it's a house symbol that pops up in the bottom right corner. And it's like a little stick figure. He's either in the house or he's out of the house. If he's out of the house, it's unoccupied. If he's in the house, you just set the bypass to be active. And so then that's where that 60-minute timer comes into play in our ECGFX program.
Perfect.
And you'll see the logic. You'll see this click on and the timer start. And then the fan will start. It'll run for its 60 minutes and then it'll expire. And if the teacher or staff or whoever's in the room, they'll have to reactivate it after that 60 minutes.
Okay, thank you.
So yeah, you can go back to the fan coil summary. You can go back to the VAV summary. You can go to the floor plan from the individual ones. And then from the floor plan, you can hyperlink to individual units. All because the floor plans are not relativized. We've linked all that data from the separate units to the floor plan. The schedule, each one of these fan coils has its own individual schedule on it. That individual schedule has its own morning warm-up routine built into it. So if any one of these units starts, it kicks the DOAS on every morning. If any one of the units were put into the bypass for the occupancy override, it'll kick the DOAS unit on. Okay. When it follows the individual schedule, let's say that fan coil 2105, let's say it took an hour and a half to get to set point this morning. It has an optimal start-stop algorithm that looks at every one of these. They all have their own. And 2105, man, it took an hour and a half to get up to set point this morning, but all the other ones, they were up to set point within 15, 20 minutes. So 2105's optimal start-stop program will calculate an earlier start for tomorrow. Say, hey, man, it took an hour and a half to get up to set point, so we're going to start 2 hours prior. Or, it could be 15 minutes prior. It just all depends on each individual fan coil. So if one of those starts early, it's going to kick the DOAS on. Does that make sense?
So the fan coil units can start independently with their optimal start routines. But
Yes.
if any of them are called to run or called to occupy, the DOAS that serves all of them will fire off.
Right.
Okay.
And how many fan coils need to be calling for cooling or heating for the chiller or the boiler to fire off?
For the chiller boiler, I was told by the engineer to do 2. If 2 or more are greater than 10% on their chilled or hot water valve.
So the minimum fan coil is 2. What would be the minimum chiller or boiler demand? Did I?
2 fan coils or 2 air handler.
I guess what percentage is the chiller and boiler gonna fire off to? Is it a 20%?
Oh no, they'll
just
go
gonna be-
to
They're gonna go all 100%?
no, they'll stage up based on the leaving chill water set point or leaving hot water set point. So let's say the chill water set point is 55 degrees. And when the chill water system gets activated, the chillers will stage accordingly to get down to 55, and then they'll back off. And then as the outside air temp increases or decreases, that set point manually, or not manually, but is automatically adjusted to go down to like 44 degrees. So if it's 80 degrees outside, you're going to have a 44-degree chill water set point. And if it's 80 degrees in the morning when these start, 2 valves open, the chill water system is indexed on, the chillers are going to try and make 44-degree water. So they may stage up to 60% or 80% or 100% before they get down to pull all that piping water down to 44 degrees. Does that make sense?
Yes, thank you.
Yeah.
And so that is essentially 2 zones in the whole building or per Jace?
The whole building.
Okay. So for clarification, for everybody's sake, there is how many Jaces in this building?
None. There's no Jaces. There's one soft Jace.
Okay. Oh, okay.
Yep.
Okay, so one, essentially for our sake, there's one global controller and it happens to be a soft Jace, a computer.
Yes, this computer is an industrial computer, and it's going to be, right now it's on the 2nd floor in G, because that was the first spot that we had access to fiber optic cabling, and that was the first section we started in, or that we were able to start installing the controls in. So right now it's sitting up there. Next week it's going to be relocated down to its own control panel in the main MDF room, main electrical room, and I believe sector A. That's where the computer is going to get plugged into the rack, and that's where it's going to live.
Now, I'm not familiar with a soft Jace. I mean, I know the term, I know the basics. Can it be, because it is virtualized essentially, can it be virtualized onto a standard IT server?
Yeah, if you, like, I've quite a few school districts that have virtual servers. And so instead of one server controlling, everything, you have, well, I guess it would be one. It's one computer that you may be able to have 4 VMs running on, right?
Mm-hmm.
Like it may have 4 virtual machines running off of that main virtual server that is hosted, in your IT department's closet 10 miles away. I mean, you could do amazing things with it. But for this building, it's just a physical industrial computer. It's the small industrial computer with cooling fins on it. There's no display, no nothing. It's just basically a box.
Yep.
And it has so much more computing power and hardware than a standard Niagara Jace. A standard Niagara Jace wouldn't be able to handle the communication load that you have going on in this campus. I don't want to call it a building because it's a campus.
So let me ask you, and let me know if I'm taking you off of the track that you want to be on. But so I thought there was going to be multiple Jaces, and then each Jace would have its sector or section of the building, and all the MSTP trunks would go to that Jace and everything. So now with this information, can you now or in this training sometime draw out, and again, feel free to do it later on when it might be more appropriate, but we want to know, or I want to know in this training sometime today, how this physically is laid out, how the communications gets from a wall sensor through back to that soft Jace that we remote into. And again, it does not have to be right now, but just keep that in mind. That's one of the things we're going to be looking for, is to understand how these things talk, because this is different than most of our sites. And we do have, just so you know, we've got a new tech with us, Mike Kraut. And so he's absorbing everything he can. He's fairly new to controls. So, we want to, look at everything that we can on this.
Yeah. So the next training that we do, I think they're gonna fly me out so I can be in person and do it. We can go over all the Ethernet stuff. One of the things that I was
Donuts?
with is the design for this building. We went back and forth from the beginning of the project, arguing with your IT department, and not so much arguing. I don't want to over dramatize it and anything, but we had a couple heated discussions, and it's like people weren't understanding what we were trying to do with this. And I was frustrated because I'm trying to explain to a mechanical engineer how HVAC networking and automation in 2022 works. And I was caught in between a rock and a hard place. And so I'm explaining to your IT department that this campus, because essentially this is the size of a small college campus, all your buildings are connected via fiber optic networks. You cannot take a Cat6 cable and, yeah, you can go longer than 306 feet, but you're not supposed to. It wasn't designed to do that for maximum output, maximum bandwidth, whatnot. Okay, Cat 5 is like 280 something feet. Cat 6 is 306 feet. So I'm like, how in the heck am I supposed to get from the IDF closet in sector G to sector F in 306 feet? I'm not going to be able to do it. I want to have my separate piece of fiber optic cable. So one, it's not on the district's bandwidth, right? Because all my stuff sits here and chatters constantly. It's always talking. I always got usage. I always got bandwidth. I'm always taking away time and space from the building's network, right? So one, we always create our own backbone. So it doesn't interfere with the rest of your networks, the rest of your IT department, and it's something you can control. That's been a point of contention on a couple smaller jobs we've done in the past previously, and it was something that they didn't really understand. And they're like, no, we want to support them. And it turns into this giant bureaucratic mess. Well, you can't have an IP address until we get the MAC address of the device you're installing. It's like, well, the device we're installing isn't going to be shipped until a week and a half from now. We can't get the MAC address out of it until we get our hands on it, power it up, and set it up. And then they get upset when you're installing the stuff saying, why isn't this online yet? Well, one, we don't have the IP address. Two, we can't get it until we actually get the product. And so it holds up the entire construction process. And I tried explaining this from the beginning all the way to the end, and they just didn't get it. So ultimately, after about 10 meetings, Derek got it. Derek gets it. He was just like, here's what we're going to do. We're going to have you sit on our network. It'll be fine. We are going to issue you guys the IP addresses. And I was just like, basically, okay, we'll just understand that we can't get you MAC addresses until this is completed. We have to physically have these on site. So that was one of the big issues that we had going on with the initial construction of this project. Is this the optimal way to do it? You know, some people might say yes, some might say no. I prefer to have it on a backbone by itself, but that's just my opinion. Does it make your life easier down the road for maintaining it if it's a segregated physical fiber optic backbone? Yes, it makes maintaining these buildings, this campus, significantly easier. With that being said, and I don't want to beat a dead horse, this is what you got. So the next thing I'm going to show you, and don't get overwhelmed because this is overwhelming. I'm going to show you all of your BACnet networks. And one of my biggest frustrations with this project going on to date is nobody wants to take a minute and listen to what it actually takes to do this. They think a 4-hour training is going to work. Well, we can do 4-hour training, but you and I both know the reality. It's going to take 4 or 5 days of training to get through this, and it's still not going to be enough. So we're going to go into Workbench here, and you're going to look at all your subordinate folders right here on the top. I'm going to click this little Discover button. What it's going to do is in the SoftJS, it's going to look at all your router tables. Okay, these are all the BACnet networks that are set up in this campus right now. What do we got? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So there's 25, 26, 27, 28. You have 28 individual BACnet networks to be able to get all this stuff to talk and pull together and talk from MSTP to BACnet IP. Now, let's say you tried to take 3 of these networks, MSTP wires, and pull them to a physical JACE that was just in sector G. And I'm talking G, first, second, third floor. Can you imagine how slow that would be? Can you imagine how long it would take to get the data to the graphics if we did the antiquated MSTP protocol? The JACE can't even handle it by itself anymore. So what they did was they started coming out with BACnet routers. The BACnet routers take MSTP and they convert it to IP packets. Then your SoftJS or your JACE and your other buildings talk to these BACnet routers, and they get data much more effectively, efficiently, and proficiently. And each one of these routers have to have different subnetwork numbers. These subnetwork numbers we based on the last octet of the IP address that was given to us from your IT department. I have spreadsheets of all these devices with the individual physical MAC addresses. I have the device instance ID numbers recorded for your BACnet routers. I have your subnet MSTP networks recorded in spreadsheets as well. And all the baud rates and everything we needed to build this and put it together. That will be an entire another day of you and whoever you want to be in this training to go through. Because that's going to be an extremely pertinent point of information you're going to need to maintain and service this campus as you go forward.
Well, I'm going to ask, I don't know if you can or would or anything else, but could you email me those spreadsheets?
Yeah.
So that I have them prior to that training?
That gets sent to you, yeah. Yep.
And then if I just want to make sure I'm understanding. So every one of those blocks that you're talking about up there right now, is it fair to say each one of those is a BACnet to Ethernet router?
Yes, they are.
Okay. So I can look at what you're showing us right now and say each one of those is a router out there that has a unique IP address, MAC address, and all that. So that's our count of MSTP to IP routers.
Correct.
Okay, thank you.
Now, one other point I just want to bring up, because it's a huge point of contention that not everybody understands. The mechanical engineers don't understand. They just, oh, it's a building automation. We'll just pull it into there. The IT department's like, oh, it's just a MAC address. We'll just pull it into there. So your chill water plant, your boilers are BACnet IP. Your chillers are BACnet IP. Part of the design of the fiber optic system in your campus did not include this mechanical equipment being standalone devices. The IT department wanted each standalone device, each MAC address. The MAC is defined, defining the network card in the main processor of each chiller and each boiler, right? They wanted those to have individual home runs pulled from that piece of equipment to an IDF room. So I was like, okay, well, how are we going to do that when I got a chiller that's 700, 800 yards from the closest IDF room in D? And they're like, well, we're not letting you put that on the network unless there's a managed switch. Okay, well, can you get a managed switch into your boiler plant or chill water plant? And then that created all kinds of issues, right? During the construction process and into where we are right now. So full disclosure, you need to know this. All your IDF closets are all managed switches, routers, racks by your IT department. Your chilled water plant has a dumb switch, meaning it's not managed. It's just a physical Ethernet 10 by 100 megabyte switch. Okay. That switch has an Ethernet cable pulled from your boiler plant, the physical mechanical room, I guess is what I'll call it, over to the IDF room in Sector D. And this will be one of the things that we do on the physical walkthrough and show you guys this.
So when we looked at the chillers, we saw there was an Ethernet cable out of each one of the chiller packages. So you're saying that each chiller has an Ethernet cable that then goes into the mechanical room where the unmanaged switch presides.
Correct.
And then from there, a single line from the unmanaged switch to the nearest IDF room.
Correct.
Okay.
Now, the reason that that's important is because all your other equipment, whether it's, let's say you go to Sector G, second floor, you open one of our control panels and you see one of the BACnet routers sitting there flashing at you. When you troubleshoot that router has a direct line pulled from an Ethernet cable, Cat6 cable pulled from the router over to the adjacent IDF room. And you're familiar with this, Kevin. It goes specifically to a port on that switch. Port 46 is this router. Port 47 is that router. Port 44 is this router. And that's how your IT department manages that. So let's say somebody gets over there and they start messing with the cables that are plugged into that switch. And they pull out port 46 and 47 and they're not paying attention. And then they plug them back in and they swap them. Well, port 46 is looking for the MAC address for the router that it's supposed to be plugged into. So this is one of the things that you got to be careful with and you're going to have to fight with. And this is why it shouldn't be on the backbone with the rest of the school. And this is why it shouldn't be managed by the IT department.
So
that MAC address is assigned to that port number. And it's not going to be happy if it sees it talking to a different MAC address on port 46. And we've had this happen several times where IT comes in and they replace the switch, specifically third floor E, and nothing talks. And you're like, oh man, I got a whole section of a building down. What's going on? And it creates this whole other level of troubleshooting that you have to be aware of. Does that make sense?
Yeah. So let me ask you about cable management here and stuff, because I've got stuff implemented in the district to minimize that. Nothing can be eliminated, but
right.
Is it fair to say that from one of the routers, for an example, your IP router, that cabling, you plug in your IP router to a biscuit or whatever, that wiring goes back to the IDF room, to the switch panel, or to the patch panel, and then there is a patch cable from the panel to the switch.
To the switch port, correct.
You guys aren't directly connected into the switch, correct?
There are some
that are panel.
No, there are some that are directly, I think all of them are directly connected to the switches themselves. And I think the intent was Derek's team, the IT department, somebody on his team they were going to add patch panels.
Mm-hmm.
And then that patch cable would be made from the patch panel to the port on the switch.
Yes. So that's the way it should be done, or traditionally was done. And that way, what we do is we put a black patch cable between the patch panel and the switch, and IT knows that black patch cords are HVAC, so they must remain in the selected ports so that they maintain the right subnet and everything. And that's how they know that there's special parameters. We use yellow for security and black for HVAC. So that's
an excellent idea. And I can tell you firsthand, well, from when I was there last month and a half ago, that had not been done up to that point.
Okay, I'm going to make a note of that. I'll get with Derek on that, because that's how we've minimized these failures. Because if it's a blue or a green cable going into that switch, they make the assumption that it's on the admin subnet, and it's just HTML, or it's oh, what am I saying? It will automatic DHCP. Thank you, Randy. And so it hoses everything. So I'll work with Derek on trying to get that changed, and that will hopefully minimize some of your concerns, because they'll know that there's a black patch cable going into port, say 47, and they'll know that port 47 must be configured special. And if they're swapping out a switch, they need to address that when they're disconnecting and reconnecting.
I think that's awesome. I think it's wonderful. And my only thing is can we please coordinate that? If you can get Derek to get us a box of black patch cables, then we can go through and push them through one at a time or repatch them, and then make sure that our router comes back up and we're good to go and there's no nothing goes down. You know what I mean?
Yep, I've got I maintain the black patch cables here. Maintenance now supports that. We're the ones that purchase them. So I've got a bunch, but if your cables don't go into a patch panel first, because that's how it should be, anything going into the IDF room should be wired to the back of the patch panels. And then there's only a patch cable that goes from the patch panel to the network switch. And that is the cable that should be, in this case, black in color for their reference. So first I need to make sure that they're getting everything wired up into the patch panels so that we can then use a black patch cable. Does that make sense?
Yeah, let me check on that. And
Okay.
I'll have Ty reach out to you about getting some of those from you.
Perfect.
And then that way we don't have as SCC is trying to commission stuff and, everything goes down. It's like, whoa, because they'll get over there and they do the best they can, and they'll start changing stuff out and not tell anybody. And then SCC might be in the middle of going through a section, and then we lose a router or two, and it creates a whole, storm of nobody knows what's going on. And it's as simple as just, a cable just needs to be moved to this port. So that would be great if I'll make a note here to follow up with you about that, and then we'll do those individually and get those set up.
So am I understanding you correctly that you're going to follow up on whether your cabling, the field IP is punched down into the patch panels, right?
Yeah. Yeah.
Perfect. Thank you.
Okay. So, yep, I got a note of that. We'll follow up on that. That'll be a side conversation we can have. While we're talking about these networks real quick, let me see here. Slide this over. Can you see my Google Chrome page?
Yes.
Okay, what I want to do is just demonstrate this real quick, and you've seen this before. We've talked about this on projects, but you may have some new people there right now. So this is the BACnet router login page. It's made by KMC. They have the best BACnet router there is. You can see the location comes through: Mountain View High School, hot water, chill water plant. It's got the device instance I was talking about. This has to be unique throughout your entire network. If it's physically connected to your IT department's network, it has to be different. Okay. So all these numbers that I've recorded and compiled, as you guys expand your building automation systems with all your other contractors you work with, there needs to be a time, and you should probably do it sooner than later, that you get a couple contractors together and you sit down and say, hey, when you guys lay out my BACnet networks, what numbers are you using? Are you going off the octets we give you? What are you basing that off of? Because at some point, these are going to overlap and you're going to be upset because it's going to be pulling data in from another school if it has the same instance ID.
Now, when you say from the octets, earlier you were talking about some of your addressing was off the last octet, but we have the third octet is the site octet. So when you say base it off of the octet, you're talking about more than just the last placement, the last octet, right?
Yeah, so our subnetworks are based off of the last octet. So MSTP network number is 28 because the IP address they assigned us was 28. The overall network number, we used the second octet because they were different between your buildings.
Right, which is the site or school subnet.
Yeah, so as long as your other contracts are doing the same thing we're doing, then we should be good and there shouldn't be anything overlapping. So, you know, if let's say Sunset was like 120 or I don't know what it is off the top of my head, but I'm just saying if it was, 10.120, then we would use the IP network number as 120 would be the base of it. And we would go from there. This happens, your Mountain View site is 62. So our IP networks are based on the 62,000 range. And you have so much data, we have different UDP ports. So we have it basically 50% of your campus is on UDP port 47811, which creates 2 network threads that you can push and pull data on, okay, through IP. Then the other half, we use the standard 47808, and that's 2 other data threads that look at network 62. So this UDP port operates off 62,011, and then the other sections that we have set up are operating off of a different network port, different UDP port that all go back to that SoftJace. So that way we have multiple streams talking to that SoftJace, that mini computer, and we're pulling data as fast as we can. Otherwise, if you just use one UDP port, UDP stands for User Datagram Protocol. And it's just it's how that packet gets put together, assembled, and then disassembled and read and displayed on your graphic. So we had to get creative on these bigger sites and use different ports, use different numbers of threads to get all that data in and talking and communicating. Would it have been faster if we would have had our own segregated, fiber optic network cable between sections? Yeah. Would it have been a little less complicated? Yes. Does it work just fine this way? Yes. And again, not to beat a dead horse, my frustration is they have 12 pairs of fiber between each sector. You have 8 dark pairs that are sitting there that will probably never be used that could have been solely dedicated to the HVAC. And if you're dedicating ports, why can't you dedicate a pair of dark fiber that goes between sections? So this is a conversation that you, me, and Marty, and then Ollie or RNC management should have. Even as a side note, for your other projects going forward, and maybe just draw it out for a bigger picture so they understand this. Like, you guys had Prairie pull 12 pairs of dark fiber. IT is only using 4. Why don't we just keep the HVAC stuff on a separate piece of glass, separate piece of fiber optic glass they can push their data through? If you go to any of your buildings, any of them on site in the district that we've worked on that I've worked on the last 6 years, you have multiple dark pairs of fiber that are just never being used. And so I think if Marty and RNC management understand that, and if I was allowed to paint that picture for them, it would make projects go much easier in the future and easier to maintain and keep track of. But long story short, that's all I'm going to go into about the fiber optic stuff. You have, what do we say, 28 backnet routers. These backnet routers you can log into. They have their own separate web interface. They have an awesome diagnostics page. You go to diagnostics, you click device status, it'll analyze the bus. It'll go through and look for duplicate addresses. It'll tell you, hey, I see a duplicate between 4 and 6, which means that, one of those binary dip switches, the address dip switches, got that doubled up or whatever. On new installs, we set all this up and go through it for you. We start all of our MSTP addressing at 4. So that way, if somebody pulls a controller out of the box, let's say you got a new technician and you give them a controller and you're like, hey, I want you to go out there and change this VAV controller, this fan coil controller, and you forget to pre-address the dip switch on it before you give it to him. He goes out there, it comes default as address 1. Then you got 2 devices as address 1. So what Distech recommends that pretty much every controls manufacturer recommends that you start analyzing or start pushing your network at 4 or higher. So you can see right here, oh, bus is unstable, analyzing. Something's not happy right now. What isn't happy? Go to the token usage, and you can see it past the token. MSTP stands for master slave twisted pair, and it pushes a token between each one of your field devices. So if you want to go through and troubleshoot this in the future, this is the first place I would go, and I would start looking at this token usage, and it'll see it hang up on a controller it has an issue with, or if somebody puts something online and addressed it as 13. With BACnet, they don't want you to have gaps between devices, so they want it to be consecutive. So you can start at 2 and go through 12, or you can, if you only have 5 devices on this network, you start at 4 and go through 9. They just don't want you to have 4, 5, 6, 7, and then skip 8, 9, 10, and then go to 11, 12. If you look up the BACnet standard that ASHRAE wrote, it was specifically designed with their token usage not to have gaps in addresses. So the reason you'll see them all start at 3 or 4, is to give you a little bit of a buffer in case somebody puts something online that's already, comes with the default address out of the box. One of the things Distech started doing is they started setting all their dip switches off. And when you have it set to 0, when you put it online, you'll see it show up green on 126. 126 is the highest address that you can set a binary dip switch to. The BACnet standard is set for 127 to account for the router. So when you look at this is why it always starts at 4. It'll start at 4 and go through however many devices we got on that trunk.
And you're viewing this, correct me if I'm wrong, but so this isn't software that we have or get or anything. You're actually going out to a Google web page that has the software and you're accessing it through the internet, correct?
Yeah, there is no special software. You own it. It comes with a device that's in the router. So all you're doing is you're hitting the IP address of the router, and then you're logging in to that router. And so you will use this to troubleshoot going forward if you have any problems in the future. So you can look at the metrics, and you can let it load, and you can see, oh, I got 3 little receive error counts. So I got a controller out there that's not happy that we're going to have to go look at. So we're going to have to find that guy, isolate it, and see why it's not receiving data. Something's trying to talk to it, and it's not happy. It's chirping back saying, hey, I got 3 receive errors. So, I mean, this is kind of an advanced tool, and if you don't use it every day, it's a little complicated, but this is what we use to set up, troubleshoot, and identify issues. It also has, if let's say in the future that you guys are having major problems, you can't narrow it, pinpoint it down, it has an MSTP capture feature, okay? So what you do is you click this little Start Now button, and then you see how the Save button up here has an asterisk next to it? It didn't have that asterisk before I clicked on this. So when I click on it and I tell it to start capturing these packets, I'm going to tell it save, and you can see it's going to start capturing all the data points, all the tokens, all the information from every packet going between. By the time it left 9, it looked through the rest of the bus, comes back to 0, picks up the first controller. It's going to tell me everything that it tried to talk to, or, hey, I left 9. I'm looking for 4. It took too long to get back around. What's your max master setup? So it'll give me all that information. So when I'm done doing this packet capture, or you're done doing it, It's up to you. If you want us to do it in the future, or if you want to get familiar with the tool and use it, you click stop now and you click save. It says, hey, I accepted that command. And now your download is complete. It turns green. And you can see down here in the left-hand corner, it'll download this packet capture. So from here, there's multiple tools that you can use to open this PCAP file. PCAP files are used by Wireshark or Optigo's BACnet troubleshooting utility, but let me see. I don't know if I have it on this computer.
And I might have missed it, but did you stop it or does it only run through once? All the way through one run of packet exchange, and then it stops itself.
No, it'll go through and it'll continuously run all the way till it runs out of memory for the packet capture itself. Then it'll stop itself and tell you it's ready for download. But typically you can find a problem within 5 minutes, sometimes 2 minutes. But I think what I'm going to do in the background here, just to show you guys this, and we'll.
And we don't have to get too deep into this because this will be in the advanced section. So if you want to save this for the advanced, that's fine.
Okay.
These guys would really be playing in the graphics. So that's what we need to make sure we stick with primarily for how we can help maintain for the customers during this transitional handoff.
Right. So as you can see, I went back, device status, bus is stable. Sometimes this thing is its own worst enemy. And if you're in here messing around a lot, now your router is adding a bunch of extra traffic to the network trying to talk to stuff. So this is a really cool tool, but you got to be careful when you use it sometimes. I just want you to be aware of it and know that it's out there. You can also, as KMC comes out with firmware updates, you can update the firmware in it. You can also manage, where is it? Under security. Let's say you want to add a new user, you know, it's up to you. It's something we'll talk about. You know, do you want it called HVAC? Do you want to call maintenance? Do you want to call this, that? And then you configure the capabilities you want them to have with it. It's kind of like administrative rights, basically, is what it is. So I'm going to hit cancel because I don't want to save this. Ignore. But anyway, you can configure who can see it, who can get into it, who can use it, do whatever. So just know there's 28 of these guys out there, and it's going to be part of your life going forward to maintain and service the building. But it's a super helpful tool, so just be aware of it being out there. As far as what they're going to be seeing from the graphics only, this is going to be displayed as your homepage. You have all your DOAS units, 1 through 9. DOAS 1 through 4 are all the same style units. DOAS 5 through 9 are a little bit different. They're different style. They're more compact. They don't have the same features as DOAS 1 through 4. And by features, I mean, when you look at the graphic, they may look similar, and they're pretty similar. The setup, the configuration is a little bit different with the heat wheel and whatnot. But the actuators on DOAS 5 through 9 are analog, meaning they're linear 0 to 100, and DOAS 1 through 4 are just digital commands on and off. I think because of the whole COVID thing and manufacturing process, they had to accept whatever was available as far as the units, and you know, trying to keep everything standard has been super complicated with new equipment at this point. But what you're going to see with the DOAS units is they all support fresh air to the individual fan coils served underneath them. You've got calculated duct static pressure set points. You've got your minimum static pressure requirement, your maximum static pressure requirement, and then the range that the engineer wanted it to reset between. So if the minimum static pressure requirement was 3,455 CFM, meaning every box was at min flow, that's all you would need. The engineer wanted the DOAS to make 1.25 inches to have enough capacity to get that 3,400 CFM out there. The maximum amount of airflow is 12,961 CFM, and the engineer wanted the machine to run at 2 inches to meet that maximum static pressure set point, which is calculated right here. Does that make sense? What I did over here to the right is I calculated the required airflow. So how I did that was I went and queried every 15 seconds. I have a program running that says, hey, what is the effective airflow set point of every box? And then it totalizes it and gives me this number. Then I go back and I look at the actual airflow. So here's what the total of what all the boxes are asking for. They're asking for 11,978 CFM, which is almost at our 12,961 CFM set point. And our max static set point we're trying to make is 2 inches. So since we're 1,900 underneath what our max is of 2 inches, it's calculated at 1.9 inches. So it constantly resets and adjusts itself based on the total required airflow. And then I put this point on here just so you can see what you're actually delivering out in the field. This is the totalized airflow of what all your VAV boxes are making. So here's what they're asking for, 12,079. And here's what we're actually delivering is 12,065. And you'll see it fluctuate a little bit here. It'll catch up. That's pretty darn accurate. It's pretty freaking close. So remember, your duct static pressure resets based on the min and max requirement from the total of all the boxes. And then over here is just a quick snapshot of what the boxes are asking for and what the DOAS is actually delivering. Does that make sense?
So let me regurgitate that back to you and see if I'm anywhere close to what you just said.
Okay.
So really, we're not as concerned about duct static as we are meeting flow. And we're using duct static to meet flow, but the flow is constantly changing based off of what the boxes report back they want.
Right.
And then you're trying to maintain what they need or what they're asking for using duct static pressure as a driver. Is that a fair?
Yeah, because typically what they've done in the past is is like a lot what you're familiar with all your other buildings is guessing. The specs, they all come written. They say, look at the dampers every 5 minutes. What is the average damper position? And then increase the duct static set point based on what the damper positions are.
Just to make sure no dampers are sitting at 100% for too long.
Right.
Yeah.
So now it's like, well, this is just demand control only. We only care about getting enough fresh air for COVID and CO2 levels into this building. So we're looking at what every one of those boxes actually needs and then resetting based off of that. And you can see, hey, we're asking for 11,000. We're at 12,114. And, you know, just updated a few seconds ago or whatever. And then the DOAS is going to look at how far apart these are before it recalculates. So we were at 1.93. We're overshooting a little bit. So it recalculated the duct static pressure set point to 1.91. So it slowed the fan down just a little bit too much. We're only making 1.8. So it'll speed it back up now, 1.91, or try and get as close as it can to that. So it's only making exactly what it needs. And this is only for fresh air. It doesn't heat it, doesn't cool it. It doesn't care about any of that. It just wants to make it. This heat wheel, it's gonna run. This is the only type of heat recovery you actually have, or cooling recovery, right? It's sucking air from your building into these honeycombs and capturing a portion of that air, and then your outside air is being sucked through from right or left to right, and then it's hitting. Let's say it recaptures the 72-degree air, and let's say your outside air is 95. It's going to temper a little bit with whatever's recaptured from this wheel and push it back through. The original spec said to maintain a discharge temp between 70 and 75. And I was like, okay, well, the unit that you bought doesn't have a modulating wheel speed. So how am I going to make a reset between 70 and 75 degrees when the wheel is either on or off? And then the engineer came back and said, well, you're not. Just turn it on or off and disregard that part of the spec.
And
okay.
what turns it on or off? What are the conditions?
That's a great question.
I thought so.
It is a great question because I don't have the set point on here. I want to say it's the economization mode. Yeah, so if the right here, sorry, I'm trying to jog my brain to remember. Econ mode is inactive. Whenever the economization mode is active, the wheel is off. When the econ mode is inactive, the wheel is on.
So when we're trying to free cool using our DOAS, we don't use the energy recovery wheel. When we aren't trying to use free cooling, we use the wheel so we can recover some of the heat.
Yes, or
Okay.
cooling, yeah.
And then can I go back to the duct static pressure reference or set point that you're driving to maintain the volume? Is there, it's really small on our screen, so we can't really see it. Is there, I'm assuming there's a minimum duct static that it's going to maintain no matter what the conditions are, correct?
Yeah, that would be your static set point out low. So the lowest it'll ever let it drive it is 1.25 inches.
Okay, so because I'm assuming in my mind, I'm thinking even if we're getting the volume we want, if there's a discrepancy down in the field or a problem with the box or whatever, we could starve out a box, but it's through the tab and everything. They've determined that 1.2 guarantees some of our furthest boxes getting what they need, I'm assuming.
Correct.
Okay.
Yep. So tab, what they did was they had us go through and set everything at min speed or min flow for the VAVs. And then we ran the actual unit at 1.25 inches to see if it would produce enough air to meet that min flow set point. Now, there's a couple of units that they're still working out some issues with. There's a unit where the exhaust fan runs faster than a supply fan. And that's between the balancer and the engineer and what the mechanical equipment can do. I don't want to go too far into that. And that's why we're not handing this over yet, because there's still some things that need to be worked out, you know? So, I mean, everything's running, everything's heating and cooling. We're about 95% there on a lot of the stuff, but there's still a couple bugs that need to be worked out, or some parameters that need to be widened, so to speak, to make the equipment work the way it was intended to. Does that make sense?
Yeah, so on the DOAS, is there, I mean, I'm assuming there's fan alarms. Can you go over or disregard if you're gonna go over what alarms could be generated from the DOAS? How do we troubleshoot them? How do we reset them? What do we need to know about alarm conditions off the DOAS?
So the DOAS have manual reset, high static safeties. You're gonna have to go up on the roof and reset them. You're gonna see down here that you have a supply fan alarm on the bottom right, or exhaust fan alarm. It'll turn red. You'll get a bar that'll pop up over the fan, say it's an alarm, like, you know, pretty much what you're used to on your other buildings.
So then that's just from a discrepancy between status and supply, or I mean, command and status.
Yeah.
Okay.
So one of the frustrating things is like we had a plan, we submitted a control submittal, and you know how that goes. You got to be flexible in this business. Everything changes, right? You don't always get what you want. The equipment that you thought, that you as a controls contractor bid off of, very rarely anymore is what actually shows up on the job site. And so we have like some units that have supply fan alarms built into the ECMs. We have other units that don't. Some units on your DOAS are ECM, some are VFD. And that's where the stuff kind of gets different between 1 through 4 are pretty consistent. But 5 through 9 DOAS units are a little bit different on each one. So you may see, some points that are on here on DOAS 3, but DOAS 1 doesn't have it, or DOAS 2 may not have that alarm or that feature or whatnot. But for the most part, they're all pretty close to each other.
Can you say again, I apologize, the supply fans on the DOAS are controlled differently between some of the DOAS?
Well, some have ECM motors, okay? Some have VFDs on them.
So this is the same as what you were saying about the fan coil units. We've got the same thing, right? Some fan coils are ECM, some fan coil units are VFD and such. Did I understand that correct?
Yeah, and depending on
Wow.
the unit, you know what I mean? It's like if they only had fan coils that were available in a certain size, you got some out there that they're 3-speed, just, low, medium, high.
Right, okay.
So then your flow set points kind of go out the window. It's like, well, medium was close enough. So that's, medium met what the engineer asked for as far as your total CFM the fan coil is capable of making. So that's, the speed you get. So.
Yep. And so the DOAS has not no 3-speed or no multiple speed. Our DOAS does have a mix between ECM and VFD, correct?
Correct.
Okay.
And, like some of the VFDs, like it'll have a VFD output alarm we can connect to. Some have an ECM motor that have internal series alarm switches that we can connect to that we can display. Some don't. So you may or may not see the supply fan alarm up here. Like this is DOAS 3. You go to DOAS 2. Yeah, DOAS 2, we don't have it on. So there may be 1 or 2 little things, but the overall operation and how it's sucking and pulling air is laid out here. But you will see a difference between when you start looking at 5 through 9. Like your wheel is back further. You have a bypass duct. The airflow station's over here.
So you went over high static. There is high static alarms on these, manual reset. We've got fan alarms, discrepancy between command and status. What other alarms on these DOASs? Is there any kind of temperature alarms or anything else that we should keep an eye out for?
Yeah, and when I turn this over to you, the next training, we'll go over that. So you have no temperature safeties on these. It didn't call for low limits.
Sure.
It scares the holy hell out of me.
Well, there's no coils in these units, correct?
There's no coils in these units, but there's a heck of a lot of coils that are being fed by this unit.
Right. Yep.
A lot of them. And can you imagine the destruction? And let me emphasize this to your team. Imagine the destruction that you can create if you go service this unit and you put a VFD in hand and forget to put it back in auto. If it goes to 10 degrees outside and this VFD on this unit gets left in hand, guess what? They ain't going to turn off.
Yeah, you're going to break coils in the building.
You're going to suck in 10-degree air through this outside air duct and push it to every one of those fan coils. These fan coils aren't easy to get to. If you had to change a coil in one, it would be not only a massive amount of money to replace it, physically get up there and replace it, but just the cost of the coils. So at the beginning of the project, I was just like, why don't we have any type of temperature safeties on these? Last week, I brought it up to the commissioning team that, and I haven't put it on the graphic yet because nobody asked me to. I just took it upon myself to add logic in our Distech controller that's in each one of these units to shut down the DOAS if it goes below 36 degrees. The only thing I have on here is just this set point in the middle of the screen, low DAT shutdown set point. I asked Dennis if it would be wise if we sent the RFI to put a big old thing on the graphic here that says, hey, you are shut down on low discharge air temperature, and make it flash at you guys. Because there's no mechanical, electrical interlock safety to shut these down.
So right now, if I understood you correctly, the DOAS will shut down if the discharge air temperature is below 32?
36.
36.
Yep. Whatever I got it set at right here on the screen. This is only low temperature safety. It's just a software safety.
Okay, and
Yeah,
that would
than
be in the
nothing.
sequence of operations for us, right?
Well, I'm not going to add it to it until they okay it, because I don't see why they wouldn't okay it, but
Well, but keep in mind, this, if a DOAS is not running, we can't occupy. So we'll
Right.
have to be, there may be times where we might have to override that and sacrifice that and keep an eye on the coils just to keep the building occupied. So we'll definitely want to, if it remains, obviously it needs to be in the sequence of operations, and it'll need to be, an alarm point that flags us, like you're saying, it turns red to tell us that, we're in that condition.
right. These wheels are really, they're pretty impressive. The energy recovery on them is huge. So the challenge is going to be what happens this fall. Like, you know what I mean? So with this campus, as soon as you start getting low ambient conditions into the 30s, we need to watch this thing really close and make sure these babies don't lock out. Or maybe initially set these at 28 degrees, you know what I mean? Until we can see how efficient this heating wheel is. How much heat are we actually recovering from this, and at what temperature can we maintain? We don't know what they're going to do yet. So everybody wants to close this project out and run away from it and be done with it. And there's a whole hell of a lot of work yet to be done. So I know you get it, and I can't express that enough because nobody else gets it.
So we're having a conversation here, and I wanted to tie that in because I think there's really good information going on a little bit separately. So let's revisit if smoke in the air, things like that. These are 100% outside air. That's what they do.
Yep.
That's all they do. There's no mixed air dampers. And even though there's filters on them, if we have smoke in the area, the only thing we can really do to keep that smoke from coming into the building is to shut down all the DOAS.
Correct.
Is there a smoke button? Has there been any software put out to, like you're saying, it's super cold out, there's some kind of environmental harm out there outside. Is there any one button type thing, or would our best approach be to go to each DOAS and shut it off?
There isn't, and they didn't ask for that in the spec, and it's something that we had brought up about forest fires.
Mm-hmm.
And I still haven't received an answer on it yet. And so, like a lot of the other school districts, like in Southern Oregon that we take care of, up in Washington and Alaska, they all have a volcano mode or forest fire mode. Volcano is a little extreme. Let's hope one of those never goes off. But forest fire is definitely one that, over the last couple of years we've dealt with firsthand, right? And it would be fabulous to have a point that you could shut down all your outside air. Because at some point you got to keep the kids in school, but at some point you got to go to zero, you know?
So
then
let,
How are you
so,
going to do that?
so we don't have that. So on this screen, we're at whatever DOAS 5 or 6, can't tell for sure. So if we've got smoke coming into the building, we get authorization, because that's got to happen way above my pay grade. That we're going to shut off the makeup air for the site. How would you recommend we turn this off in the middle of the day to have the least adverse impact but still shut it off so we don't bring in some of those contaminants?
That's a great question. I would start on the main page and put a global shutdown button, like global outside.
Right. But what I'm saying is we don't have that right now. So assuming that that's not going to happen, because right, it's not in the specs to do that or anything else.
Yeah.
What, on one of those graphics, what point should we be changing the state of? Is there a point? Is there an occupied point you recommend we change the state of, or how would you recommend with what we currently have to shut that down?
Okay, so great question. And it's going to be this unit command point. There is no, start, stop, occupied command with this. It's a unit command. This unit will not run unless this single point is commanded on. And what this does is this activates a binary output on the controller. It then energizes the outside air dampers, whether they're 0 to 10 or they're 24 volt on or off. The outside air dampers open.
Unit command.
Yep, unit command. And once that safety circuit is completed and the end switches are closed on your outside air and exhaust dampers, then the unit will start. So this unit command is what you want to override on or off.
And if I understood you correctly before, this unit gets its start command not from a schedule, but from fan coil units, 2 fan coil units coming on, correct?
Yeah, it's basically there's a global schedule for all the fan coils per sector, like a master schedule, so to speak, that they follow. And then each one of those has their own optimal start stop, whether they start earlier or, follow the normal schedule. So the DOAS unit, let's say none of the fan coils start early, the DOAS unit will come on when the fan coils just normally start.
So the DOAS comes on if any of its fan coils come on.
Right.
Cool.
Yep. So unit command is where you would want to override it on or off.
Okay. Awesome.
And this schedule command is just looking at the master schedule that the fan coils are following. So the key points, economizer mode. If the economizer mode is inactive, the wheel's on. The economizer mode's active, the wheel's off. It's just reverse. You can override your fan speeds. You shouldn't have to because everything's balanced and set, but obviously, doing maintenance, this or that, you want to do that at times. So those are overrideable. Heat wheel failure, if the command versus status doesn't match the heat wheel, you'll get a little button that flashes and then this will turn red. Same for the dampers. High static safety, the key point on that is that it's a manual reset. And then supply and exhaust fan alarms. If you don't see a button up here that says supply fan alarm, exhaust fan alarm, it means that this is a software alarm. If you see a button up here that specifically says, supply fan alarm, exhaust fan alarm, then that means we're monitoring an actual internal alarm on the VFD or the ECM motor. But if you just see it down here by itself, this is just logic that I wrote that says, hey, the fan is commanded on, does the status match?
And there's nothing to reset with that. That's just letting the operator know that you're in that condition, and then you'll have to physically correct that condition and then that alarm goes away. Is that correct? That alarm, essentially I guess what I'm trying to say is there's a mismatch between command and status. It goes into a fan alarm. You don't take away the command, right? There's
Right.
no reset. It's just repair at that point.
Correct.
Okay.
Now, that is a great point. Now, last week we had a DC under voltage alarm on several units. And you'll see that on the graphic, it was just into alarm. Or the fan was in alarm, was commanded off, but the status was not running, or commanded on and the status was not running, excuse me. But yeah, at that point, you'll have to go up to the roof, check the unit one to determine if it's an ECM or if it's a VFD. And you know what I could do, Kevin? I could put a little note on the graphic, because these DOAS units are individual graphics, that I could say this unit has ECM motors, this unit has VFD motors, or these outside air dampers are 0 to 10 volt. These outside air dampers on these units are 24 volt on or off,
The control drawings will show that, won't it?
The control drawings will, our red lines will,
Yep.
yeah.
That's
But
good
I don't know
enough.
if you wanted that detail on these graphics.
No, because we don't have it on any other schools like the dampers and stuff. It's up to us to know what actuators they are. And as long as the control drawings, which we use heavily, the control drawings show that it's using a Belimo XYZ 0 to 10 volt actuator, that's where we'll look up for that stuff.
Okay. So speaking of that, on this main page, what I'll do is I'll put a button up here with a PDF of our as-builts when they're done. And then that PDF will show each one of your floor plans and how we pulled the communication wire, where the router is located, give you all that like as-built information. So as you guys are trying to service the building, you'll have that reference. So it'll save you a bunch of time and you're not popping ceiling tiles everywhere trying to find this or that. That's something we haven't done in the past projects. I think we should do because we have it. So we might as well just put the PDF up here and it's right here for you every time. Let's see. The Evergreen main, I'll put the button on there when I'm ready to hand it off to you guys. For right now, any temperature complaints, they all go through Skanska and Apollo, and then they get filtered out as needed. Floor plan, there's a main button on the floor plan.
Can I get the IP address for that?
For the,
Because we still have some response on that for visibility and stuff. Is there a way I can get the IP address to go directly to the soft J's?
yeah, it's right here. Top left, can you see it? I'll email it to you.
Okay, perfect. Yeah, I can't, it's showing up so small, I can't see it, but I don't know if it's so small because it's, we're doing the virtual. So I'm assuming that all of these screens will auto scale because right now we can't read anything. It looks like there's a lot of stuff on that Mountain View main page.
It's because that my monitor is a 32-inch monitor.
Okay.
And Teams meeting doesn't know how to pass the resolution through.
Okay, perfect.
So
or you can give us all 32-inch monitors.
That's not in the budget.
Oh man.
Okay, I'm emailing you the IP address right now.
Thank you, sir.
And then the next training, we'll go through and set up the users. I copied the users out of probably Sunset or Harmony or somewhere. So, I got the usual suspects. I got Kevin, I got Marty, Randy W, I got Jeff. Obviously, we got the SCC in there. But if you double click this, let's see what it does here as far as passwords. So what happens, and just so you know, is when I copy these previously made passwords with these settings into another database, you see how the password isn't filled in?
Yep.
So what I do is I make my default password, capital H, lowercase DAC, 1, 2, 3, 4, 5. Oops, I just fat fingered it. Exclamation point. Oh, excuse me. So I put the default in there. Did I fat finger that again? Slow. There we go. And then there's a little thing here that we toggle. Force reset at next login. So your normal login, when you go to do it the first time, use that HVAC 1, 2, 3, 4, 5 exclamation point, capital H only. You get that red screen that pops up. You remember, remember what I'm talking about?
Yeah, so we're gonna, in order to do the forced password reset, we're gonna have to go in to a secured HTML.
Yes.
Okay. Yep.
So to do that, you would type in https:// in your browser. It says your connection is not private. You click advanced and proceed. To get that, to go away, Derek, we would have to talk to him about getting a certificate through whoever you guys use for your signing authority. I'm sure he has like DigiCert or somebody that the school district uses. So basically, we would generate a certificate and give him the private key, and then he would use DigiCert or whatever company that they use to sign that web certificate, and then we would download it into the SoftJS, and then you wouldn't get this little not secure HTTPS crap. Basically, they're probably not going to do it because they don't want to spend the money on it because it probably costs $500 to get the certificate, because all this stuff is sitting behind your firewall anyway. And basically these secure certificates are just the internet nerds created a scam to charge people money. So if it's behind a firewall, nobody really cares. So anyway, so let's say we go Kevin, and then you use that default password I just made you, capital H, then BAC 1, 2, 3, 4, 5, exclamation point. Log in, you get this reset password window, and it tells you how many characters, da 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 da. So when you're ready, Kevin, just do what we just did. You know the feel. You put in your password, it'll update it.
Now, one of the things that I'd like to do for now is change the parameters in one of the services so that we don't have to go, so that we can go down to 8 characters. Is that something you want me to do? I've been doing it on all of our projects as we go to put people in, because some of the passwords that we're trying to maintain right now are 8 characters. 8 characters. So I didn't know if you wanted me to do that or you guys to do that.
Yeah, you can do it since it's a security setting. If you're gonna lessen it, then yeah, you do it.
Okay, perfect.
Yeah.
That's what I was kind of wondering.
Let's see. So basically, in a nutshell, it's just a overview. Here's what you got. Here's what you can kind of expect. We're still working on a bunch of stuff. The basic layout is here. You have all your DOAS units. You have your corresponding VAV summary. And then right across from that, you have your fan coil summary. This column over here, you've got your water systems, exhaust fans, radon fans. All your radon fans should always be on. There'll be an alarm if the status is off. Obviously, those need to run all the time.
Those are all radon fans?
Yes.
Wow.
Yeah.
There's a couple of them, huh?
Yeah. We need to, one of the things we're working on is getting the room numbers they're actually in. So we'll put like room, 409 or 209 or whatever the hell room it ended up in. So.
And that's where the physical fan is located?
Correct. Yep.
Okay.
That way you guys can find them. But all these, it's kind of like the last thing on our list to get done. But we got all these little things yet to massage and do. Let's see. It's a different. Go back to the main.
Fire alarms is what happens, is there any units, any rooftop units that have duct detectors, smoke detectors in them?
Oh, that's a great question. There are. I don't think I have it on here. Let me look. I
'Cause-
want to say Sector D, Air Handler 11. There are fire dampers. And I do have a controller monitoring those. They got added, and I got to put it on the graphic yet. Let me make a note of that. There, we do have a fire damper status. I want to say it was only Sector D. And it was one of those after things they had us put a controller in to monitor them.
Because
And
traditionally,
D is
any, any air handling device over 2000 CFM requires a duct detector. And then typically that duct detector, and that's detecting ion or smoke, it will be hardwired to the air handler to force that single air handler to shut off if it detects smoke or ion. And then it's tied into the fire system. And so obviously it tells the fire system that there's an issue. And that more than likely is just a trouble or supervisory at that point. But when the fire system goes into a full-fledged fire alarm, we typically through the DDC have a point where the fire system closes or opens a set of contacts to the DDC. The DDC sees that as a fire alarm, and then it via software shuts down all of the air handlers, all the rooftops. Are you aware of any of those types of logics taking place?
Yeah, we do have. I don't know where it is off the top of my head. I want to say it was in the hot water controller.
For
There's a
that single
point.
point from the fire?
Yeah.
Uh-huh.
I'm looking through the points list here just to see if it's in there. Because that point I could put on all the air handler pages.
And we would want that, you know, a fire point, so to speak, that goes red, essentially to tell us, you know, like your example that's on the screen right now, air handler 11. If air handler is off and we're trying to figure out why it's off, we would want a status point that says fire and it's red. And that tells us that, oh, it's off because of the fire alarm. And then we would expect to see that on all of the rooftops, because I'm assuming your logic is all of the HVAC equipment besides possibly some critical or strategic exhaust fans, but primarily all of the HVAC equipment goes unoccupied or off for a fire event. Is that what you're recalling?
Yeah, it does. I don't recall where we're monitoring that point from,
Okay.
but yeah. So we have the smoke alarms that we're monitoring on each unit. That's on the safety circuit of each unit.
And I'm assuming that only turns off that particular unit that has the smoke alarm inside it, correct?
Correct.
Yeah, okay.
I'm gonna have to find out for you because I don't have it on here.
Okay.
I see we have emergency shutdown, but I think that's the boiler emergency shutdown. And I have the fire pump alarm, which I will have to make a miscellaneous graphic page and put that on. So I got
'Cause
fire
we're
pump
not-
alarm.
We aren't doing anything directly. The DDC doesn't control anything on the fire pump. It doesn't change anything or control anything on the HVAC systems based off of any monitoring on the fire pump, correct?
Correct. It's just,
They've just
monitor.
asked you to monitor the fire pump, and it's not unless the fire system, the simplex system actually goes into a general fire alarm that then you would shut down all the air handling equipment.
Correct.
Okay.
Let me find out where we're monitoring. I know we have it in this database somewhere, but I think probably what we should do is put that put that point specifically on this main page, maybe over here to the right of the outside air temp. And then also put it on the air handler pages and the DOAS pages.
Mhm. Yeah,
Um,
we definitely want it on all the air handler and DOAS pages, because that's where, you get a call from somebody. Let's say something happens and somebody resets the system, so now there's no horns and strobes. And then, Randy gets a call because teacher X is too hot, and he goes and looks at her DOAS, and says, oh, well, it's off. That's the problem. And then, but why isn't it running? And then he spends an hour trying to troubleshoot. So we definitely would want that fire point on all the air handler screens, because that's typically where our troubleshooting is going to take us straight to. And then it would flag us with a red icon saying, oh, that's why it's off. It's in fire alarm. Okay, now he's got to troubleshoot. Why is it still there?
Yep. Let me make note of that. And then what did we talk about earlier? Do you want that, like that global, you wanted to just say like global shutdown? Because I need to be able to put in an email and send it to SCC and BlueMac for like, shutting off outside air during, forest fire or whatnot. You want it like OA shutdown or global OA shutdown, maybe? Like what would you want it called that makes
Let me look, because we've got a couple sites that have it. Let me see how we're calling it there for consistency. So let me send you an email with what we're using on other sites, and we'll just go off of what's already there.
Yeah, just send that to me and I'll make it so.
Cool.
One other thing I wanted to touch on real quick was these VFCUs. So you can see that we got one of them an alarm right now, 202. It's 79 degrees. They said to keep it 78. I think it's just mostly like the IDF rooms is all they are. From this summary, you can, let me just randomly pick one, double click it. And I made two different graphics. So some of them are just like a wall mount unit above the door, where it's just this, rectangular cassette. These are all Daikin, and they have an Intessus BACnet integration module built into it. So basically, the Daikin main processor is Modbus. It talks to this Intessus little box that's Modbus. And then we talk to the Intessus box, which is BACnet. And this is the data that we were able to get out of it. We were able to get like a unit status, fan speed status, the mode status. I made it so the set points are override, auto, and set. So this is one of those things where it's like last one wins. So you can stand there in front of the BRC thermostat, the Daikin thermostat, and you can manually change it there. Or you can do a set. So let's say you set it to 72.1, then the DDC wins and it's at 72.1. But then if I were to walk back in there to that stat and change it to 72.0, then the stat wins. So it's local control or DDC control via set. Now, if you do an override, the DDC is going to continuously write that point every few minutes back to that thermostat. So if somebody locally changed it to 71.0 and you override it from the DDC to 74, it's going to stay at 74.
So I have a question. On a lot of these new sites, I'm finding that contractors are not following what should be in the contract, and that is hardwired. I'm going to call it a thermostat for these mini splits. Do you happen to know, instead of relying on the wireless battery operated thermostats, do you happen to know what's going on this site with those? Whether there is hardwired thermostats that do not take batteries for this?
Yes, these are all hardwired.
Awesome.
Yep.
Woo.
Yeah, that's a nightmare. I wouldn't recommend you. You should probably write that into your spec. not to have
It
wireless.
should be in there because we've had so much problem with it, but I just went to a site, a very large middle school that is all battery operated right now that I gotta figure out the contract issues on, but yeah, because we should have it in the specs that it's supposed to be hardwired, so we don't have all the batteries to deal with.
Yeah, a lot of the facilities guys for the school districts, they get the Mitsubishi units that have the wireless remote. And you have to disable the remote, like you have to physically take the batteries out of the remote to let the DEC be able to work with it. And I was just thanking God we didn't get those on here because that's a nightmare.
Cool.
So basically you got, room temp, set point logs or charts or whatnot. It's not going to do it because I'm in Workbench, but if you open the browser, it'll load it. Let me go back to it. Unless I have my HTML5 button activated when I'm in the Workbench environment, it gets all goofy. So VSD summary, let's go back to the summary and let it load real quick.
At one point, I was in a meeting and there was conversation that a lot of stuff was running 24/7 for, and I'm thinking it was primarily chillers and boilers, chilled water systems, boiler water systems and stuff. Do we have those back on schedules now?
Yeah, it's because somebody left DOAS 6 overridden on. And so I confirmed last week, Friday evening, that everything's shut down, the plant's shut down. So I don't know if it was during commissioning or whatever, somebody overrode it on.
So a DOAS, okay, interesting.
Yeah.
And I'm assuming that, let's say somebody overrides a DOAS on, or it stays on for whatever reason, and we're running into the night and it's 40 degrees out. I'm assuming that chillers aren't going to run, chilled water pumps aren't going to run because we've got still outside air lockouts for those.
Yeah,
Same with
or
if
it's
it's super
actually-
hot for boilers, right?
it was actually DOAS 6 and Air Handler 14 were overridden on. It wasn't actually DOAS 6 that was keeping the logic on, it was 14.
Okay.
14 has a chill water valve. And so it was calling for cooling, trying to cool all night, and it kept the chill water plant on. And then DOAS 6 was overridden, and it affected. It was the normal schedule that was overridden from the graphic, so all the fan coils were overridden on associated with DOAS 6.
And that kept DOAS 6 on because the fan coils were on.
Yes, so it's kind of the self-licking ice cream cone happening.
So with the air handler overridden on, we still have, with its chilled water valve open more than X%, whatever, the chillers were still enabled, but I'm assuming that the outside air lockout would still be in play to keep them from running if it's too cold, correct?
Yeah, if it goes below, whatever we got it set at, I think right now it's like 54 degrees or something, or it's got to be below, chill water has to be above the lockout set point, and X amount of valves got to be open, and then it goes through its startup sequence, and it has like a 15-minute on delay time, and then when it goes through its shutdown, your pumps do a 15-minute minimum run time, or 30 minutes, or whatever it was called for.
Okay.
But we'll go through all that when we're on the next training. The chill water plant, hot water plant will be a whole day by itself. But we still got to get some things figured out with the loop pressures and what they're going to do with that whole thing, because, you know what I mean, the pumping sequence might completely change again. So I don't even want to go down that road yet, but
Sure.
we know that to keep the building stable, we have to maintain 20 pounds. And on paper, the minimum differential on paper to be able to push water and at the right GPM and maintain the discharge air temp to be able to get down between 55 to 58 degrees. On paper, it says we have to do a minimum of 6 pounds. If we run sector H at 6 pounds of differential chill water pressure, you'll be lucky to make 68-degree discharge air when you got a 44-degree loop going. So we're still trying to finesse that, get that figured out, and see what they want to do about the pressures, and maybe they're going to add a valve or two, or who knows. So we're waiting to hear back on that. But the system works; it's stable.
It just has to run just about wide open just to maintain enough flow.
Yeah, I mean, pretty much. I'll go back to that, but let's just take a look at the chill water system real quick. Pretty much the minimum speed is 100% for one pump, and then right now, as the pressures start dropping below 20 pounds in H, then we'll stage on the second pump, and then it'll stage between 0 to 100%. And then if this continues, this sector H differential pressure up here in the bottom right corner, right now is 20.9 pounds. If this were to continue to drop, like let's say 15 pounds, then it'll kick pump 3 on, and then pump 3 speed will stage 0 to 100% to get back up to that minimum, whether it's H, F, or G. It's always going to be H, because H is the furthest away. It's the hardest building to pump to.
So I again can't see it, the details very well, but is it fair to say that you have a single differential pressure set point of that, let's call it 20, and then none of those that's listed in the upper right hand corner can be, if any of those start going below 20, it starts to ramp up. So it's always looking for there's an algorithm in there looking for the lowest differential pressure reading, and that's the one it wants to make sure it maintains above set point, which is 20 right now, correct?
Correct. It's exactly right.
Thank you.
And then the other thing, just to note real quick, and like I said, don't get too wrapped around the axle with this the way it's operating right now, but the minimum bypass percentage is 35%. And the sequence of operation we originally got contradicted itself several ways. And it's like, it says the control to the minimum differential pressure, but also control to the plant pressure. And it's like, well, you can't control it both at the same time, so pick one.
And why is there a minimum bypass?
The minimum bypass is to maintain enough water through your machines. So the other part of the original mechanical sequence, it called for the minimum flow through the chillers. And I'm like, okay, well, we should do that with the bypass valve, not the pump control. And then I was thinking, well, maybe it should be a combination of pump speed and the bypass valve. Well, it turns out that we got plenty of pump speed, because just to maintain the minimum pressure, we got to push out to H. But it originally called for a minimum pressure drop across the chillers. So I kept going back to Carrier, and I'm like, okay, well, in your machine design, every other job I've done for the last 25 years, you have a minimum design pressure that comes with the startup sheet, on the chiller. And I'm like, what is the minimum delta P I got to maintain across each one of your barrels? So finally they come back and they say, okay, it's 6 pounds. I'm like, okay, well, where am I, the mechanical drawing didn't tell the mechanical contractor to install pressure differential taps before and after the chiller bundle on each machine. And so then the engineer came back and he's like, well, just get it through BACnet. Okay, so I looked through BACnet. Well, guess what? Carrier got rid of the pressure sensors on their machines, and they just do a thermal dispersion switch for their flow switch. So I can't read it through BACnet to tell me if it's 6 pounds, 8 pounds, whatever. So what we found by trial and error is we have a flow meter. That's because you pump through the machines no matter what in your plant. So we have a flow meter coming back from the machines. And if I go below 150 gallons a minute, then the machines trip out. It doesn't matter if one or both is running.
And is that, I'm assuming that is right above your cursor, right before the bypass?
Yeah, right where I got the hand. I've got that hard coded at 150 gallons a minute.
But I mean, where's it physically in the loop?
It's so right up. Can you see me moving the thing here?
Yep.
So it's actually in the pipe, going from outside back into your chill water plant, your pumping plant. So it's in this return line from the machines right before the bypass valve.
Okay, so it's before the
this-
bypass.
Yep. And then just to kind of cover our butts, we put the plant pressure sensor in there as well. And if there was a tap out at the machines that I could see across the chiller bundle, I guarantee if you get, you know, probably down to 142, 143 pounds is where I saw it tripping. That's probably where or sorry, not pounds, but 143 GPM.
GPM.
If you were to have a pressure drop or pressure sensors, you'd probably see it dropping below 6 pounds. So this is going to be our minimum right here. And with the campus being as big as it is, during lower ambient conditions, like when it starts cooling off and, you know, 3, well, maybe 4, 4:30, 5 o'clock, especially over the last week, I've seen chill water valves all start to close down. And so a week and a half ago, we had a couple intermittent trips, and I went back and started looking at all my valve positions, and everything was shutting down. Like our air handlers were economizing, the DOASs were bringing in cool air. And it might have been 2 weeks ago, but anyway, when we first saw that, it's like, oh man, my chiller started tripping because I was pushing water out to the building, but yet it wasn't enough. And so we were trying to massage that in, and the valve at 35% is eliminating all these nuisance trips. So I think like Legacy is another building where it's kind of like a mini campus. You got 3 buildings with one central plant, you know. And that one ended up being like a minimum of 45%.
Who's the engineering firm for this?
I want to say it's Glumac. This is a mechanical.
Because it just seems very inefficient to have both differential pressure variable volume pumps with a bypass.
Yeah.
Because and a flow meter, if you've got a flow meter and you're maintaining flow, you don't need the bypass. You have to push it all the way through the whole building, but right now using that bypass just kills energy. It just seems very complex and redundant.
Yeah. I mean, at some point, it always takes the path of least resistance. Well, it always does, period. But
You know, instead of having the logic of, we're going to maintain a minimum of 20 pounds differential in any of your zones you have listed up above. And you must maintain a minimum of 150 GPM. And if we drop below either one of those, pumps ramp up to maintain.
and that's why, you know, when I go back to the engineer and I'm like, okay, well, pick your battle. Which one do you want me to do? Because they'll describe all 3 sequences and tell me to control all 3 at the same time. It's like, well, that's not how that works.
Right. Yeah. See, I've seen this exact setup without the bypass, and we used a low select, whichever flow. In fact, we did it at Union because we were having flow problems. We did a low select off of, if GPM or differential pressure, whichever one goes below set point, that's what controls to ramp up pumps. So the pumps are always maintaining at least, in this case, let's say 125 or 150 GPM and at least 20 GPM in our lowest zone. And if any one of them slides, the pumps ramp up.
Yeah. See, the problem that we're seeing is when the system goes unoccupied and all the valves start closing off at once, the bypass needs to react really fast because the machines still control to try and make that 44-degree water as the building goes unoccupied. And then once the air handlers start shutting off, then it indexes the chill water plant off. And then it still has its 15-minute runtime, right? Its minimum, or sorry, not its minimum, but its stop delay.
Mm-hmm.
So that's part of the problem we're running into. Yeah, can something be done about it? Yeah, probably. Maybe maybe I say, add some logic that says, well, increase the bypass min position at, 430 every day from 10% to 35% is the minimum. Just so it doesn't trip the machines when everything goes unoccupied. But yeah, like I said, trying to learn the personality of the building and
Right,
how
right.
fast everything shuts down and closes. It's, we're still figuring that out.
Yeah, it seems like that it's be interesting to see the relationship with all the three-way valves, because that's typically how you would do some of this tuning, is based off of three-way valves out in those zones so that you guarantee minimum flow. And it sounds like we may be butting up against the engineered minimum flow.
I should probably look at the valve schedule before I say this, but I'm pretty sure there aren't any three ways.
And that is exactly what from what you're saying, that's the way it sounds, which is no wonder we're having flow problems.
Makes it very hard to control. If there is, there might be. I'm 99% sure there's one three-way valve.
Wow. Yeah, that right there is why we're battling and having to use a bypass, I can tell you. Okay, well, this is good education for us. I mean, there's not much we can do about it, but it definitely makes us more aware of a weakness in the hydronics.
Yeah. I mean, for a while there, we were running 2 pumps 100%. And then as we got the kids into the building and then learned the load that way, went through the tuning, doing the loop tuning for the chill water side of it, was able to get the pressures down more. I was able to figure out the minimum flow set point. But now I'm going to have to basically start over from scratch and do the same thing to the heating system here over the next week or two. So, I mean, I'm anticipating handing this over to you, like first, second week of November, maybe in there. So, here pretty soon. It's just still got quite a bit of stuff to get through.
Sure. And where, with that being said, so if I understand correctly, there's SCC is doing commissioning for the district based off of some of our standards in previous sites. And then Collins is doing some commissioning for, I think, on behalf of Skanska. Is that still, am I correct with that?
Yeah, so much. I mean, basically, Colin is just doing the commissioning for completion.
Okay.
Like, okay, here's what they asked us to build. This is what got built. Did we do that part of it? Yes or no? And
so
then
he's trying to meet the contractual requirements for Skanska.
right.
So where are we at with SCC and I guess Collins? I guess it doesn't matter Collins' final role, but do you know where we're at with test and balance and commissioning from SCC?
The test and balance is done.
Okay.
SCC did some tab verification, and last week there were some questions about some airflow missing on DOAS 7, and there's these car dampers that Daryl wasn't accounting for, which was like 3,000 or 4,000 CFM. So we thought we had a major problem, and then David from Neudorfer did a great job with the system, as complicated as it is, and went back and showed them where that airflow loss was coming from and why with those car dampers. Other than that, the balancing's pretty much done. It's just a little verification. SCC is very thorough, and they're going through asking a lot of great questions. And it's just, they're bringing David out every week, and he's going through it with them and summarizing how he got what he got. And there's still a few things, to be honest. Like I want to say DOAS 5 airflow. They're going to have the engineer go back and look at the sizing of the supply fan. There's just a few things here, tweaks and whatnot. Nothing, out of the ordinary for a project this size. But yeah, there's still a few things they're going through trying to get squared away.
So we're coming up to what we would typically be our lunchtime at 11 here. It's been a lot of information. is the plan right now, can we take a lunch? And I would almost recommend we reschedule, since this is so intense. And it sounds like there's a lot of stuff that is that is not complete yet, that would require us to just regurgitate it all over again, to save us time. Is that your plan? And obviously Skanska's gonna, have to weigh in too. What are you doing? Shh.
So my plan was just, we've spent 3 hours on this today.
Yeah,
This is plenty for the first go around. And part of my frustration is, the construction team should understand that this isn't just a 4-hour training, check the box and we're done. This is a massive project. We're talking 4 or 5 days worth of training, on a realistic level. And then, as always, we're here working with you guys after everybody's left and gone, the project's done, but realistically, there's probably going to be 3 or 4 more full day training events. But contractually, what did they, the architect and engineer put in there? Did they put 4 hours, 16 hours, 8 hours? I couldn't tell you, but it's going to take 4 or 5 days to get through all this.
so because of the size of the school and everything else, and the fact that we don't have control drawings yet, to follow along, we were hoping to meet with Ty, before this, obviously, and we haven't been able to do that. It's tough to rationalize what's there because we haven't seen any of it yet. We haven't seen the equipment. We haven't seen the controls or anything like that. Are we at what you would consider a reasonable stopping point where you've covered the basics of what's complete enough for us to absorb? And now we're going to have to do another training session as things come online or get more completed in the graphics. Is that a fair statement?
Yeah, I mean, the graphics are pretty much done other than a miscellaneous page here or there. There's still going to be some changes to some of the air handler sequences, the chill water sequence and the hot water sequence. But for the most part, everything's cooling fine. We're going through the heating system here as the temps start dropping. I'm thinking you guys are getting a warm up here this week, aren't you? In the 80s.
Yes. Yeah.
So-
This weekend's going to be like 84 or something like that for both days.
Yep. So we'll get a good transition from hot back to cold, over the next week and a half. And we got a bunch of tuning to do yet. Basically, it's just loop tuning, dialing the building in, like the fire shutdown, outside air shutdown stuff. We got to get through commissioning. There's some graphic stuff that's going to change. SCC's got some comments. There's a whole nother thing with the energy meters. We're trying to work out. So that's the least of my concerns, but it's just a few other things. So, this is a good initial start. This is all I really wanted to accomplish today. I think we went pretty good into the weeds a little bit, and
that was
you
really
guys
good
encouraged-
to just kind of see the big overview of how this stuff is piped, the major equipment that gives us the room, the zone control and stuff. So, we're at a point where we're going to need to stop just from eyes crossing and everything.
That's fine. Just one key, a couple key points real quick, and I'll wrap it up. When you guys take over the system, it's going to be laid out very similar to this, the same format that you have throughout the district. You have all your DOAS units. To the right, you have your subordinate VAV fan coil systems. Toward the bottom, after you get past the DOAS units, you have the air handlers. DOAS 8 is the only one that doesn't have VAVs attached to it, so there's no button there for that, obviously.
So it's fair to say that going from, left to right, like you were showing, the DOAS to the left is associated with the stuff on the right. Am I looking at that correctly? Is that the relationship you were making?
Yes, from left to
Okay.
right, go straight across the associated.
Those are all related.
Yep.
Okay.
And then you have your hot water, chill water plant, exhaust fans, radon fans, domestic hot water system, we'll get into that next time. That's a whole nother animal. There's multiple components with that. I don't even want to discuss that today. And then the one thing I wanted to leave you guys with was this VFCU summary. They're those Daikin standalone IDF rooms we had started talking about, and we kind of went on to different subjects, but I just want to bring these up real quick. These are all the IDF room temps. We left off, you click on the hyperlink, it takes you to the wall cassette. I did 2 different graphics for this. Some are cassettes, like the square cassettes that are in the middle of the ceilings, and other are wall modules. So I did 2 different graphics to represent, what you were dealing with for those 2 rooms. You have 5-degree above and below set points for the room temperature alarms. They'll show up in your alarm console. Just very basic, straightforward. You override it, set it from here, or you do it from the wall module.
Do you happen to know if the wall module, so typically we lock those out? Do you happen to know if that's feasible, or is that something for Apex?
It's Apollo needs to do
Or
that.
Apollo, I'm sorry.
There's admin rights, and it does say that in your specification that they need to set those up, but I don't know who they use to actually set those up.
Okay.
So I don't know.
So Joe, that's definitely something we're going to want. And I think we typically work through Sam on that, and we certainly can, but that's, we're on our walkthroughs on the mechanical and stuff. We're going to want to make sure that those are getting locked up so that staff and even construction workers, I keep walking through, not necessarily this site, but this site has been one of them. And people jack the set points all over the place. We're going to want to make sure we get those locked down with us. Traditionally, it's a cooling set point of 75, but maybe we can make that as part of the training for the mechanical is how do we lock them down, and we lock them down as part of that walkthrough to make sure it gets done with our set points. Might be handy.
Yeah, it does say that in the spec that they need to do that. So.
Excellent.
So just one last note, the next training going forward would be like the makeup air units, the interlocks, the standalone control, and we'll have Ty has so much information to give you guys and show you all the ins and outs of the buildings. So that'll be like probably just a day to go through the makeup air units, the walkthrough. We're going to need a full day to go through the chill water, hot water system. I'll probably fly out and do that. So like I said, expect 3 or 4 full days or partial days of going through this stuff going forward. And the next couple weeks, we'll finish up this loop tuning and whatnot and get some questions answered by the engineers and get it dialed in. But I'll quit running my mouth. I appreciate your time today. As always, you got my info. Contact me if there's any issues or problems. All the temperature complaints or whatnot is still going to continue to go through Skanska, and Ollie is working on, letting the teachers know that there's a district standard set point of 73.5 degrees. And I think since he made that point, the complaints have dropped significantly. Other than last week, there was 2 temperature complaints. Friday, Ty logged in. Again, we were at 73.5 degrees. They don't hear the unit running, and it's just going to be them learning to deal with the building.
Education.
Yeah. And so hopefully they'll get used to it by the time you guys get it handed over, and you won't be dealing with all the.
Well, I know there's going to be a push from, just to keep things moving forward reasonably well. Skanska and RNC management's going to want to continue with the training and make sure that we're moving forward so that everybody's showing completion at different points. So who on your side do we work with, or I guess I'm just throwing that out that we'll want to start scheduling as soon as we can additional trainings. I am going to be out all of next week. So depending on what the training is, the guys are clapping here. So we wouldn't do any high level training there. I would like to be as much a part of the training as we can, although we'll be recording it. So I think for Skanska's sake and Ollie's sake, we're definitely going to want to show some scheduling on that, just so that we're not just saying, oh, we got to do more training, but there's nothing out there. So I think the sooner we can actually start scheduling some of that up, that gives Skanska and RMC management a little feels good that there is dates there. There is, we are showing that we're moving forward on that. So keep that in mind with your side. And I don't know if that's through Tony or whatever, but we're going to want to probably start putting things on the calendar as soon as we can.
Yeah, realistically, I mean, we need a couple 2 weeks yet to work through the heating side of this. And then I in my mind, I'm seeing like the first week in November, like somewhere between like the 31st and the 4th. We spend, another couple hours going through some stuff, and whether or not we can get a walkthrough with Ty scheduled in between the next 2 weeks, maybe we can do that. So I'll have Tony float some dates out to you guys, and
Perfect.
but that's realistically, that's where I see it happening. I get so frustrated because everybody acts like, oh, this is just going to be a couple hour training and we're done. And it's like, come on, man.
Well, if there's a way that if there's sections of the building or specific equipment or graphics or whatever that we can move forward on in training before that, I know that's everybody's preference. So just ponder that and see if there's anything that we can do certainly before November. If there's specific things that you see, oh yeah, we can certainly spend a few hours on this or whatever, and we can get that scheduled earlier. I know that would give everybody a feels good. So we'll leave that up to you guys. Know where you're at and what the systems are. We're just coming up to speed on just some of the basic engineering. So whatever you can do to help us move some of the training forward, and just let us know through Ollie and Tony and Skanska.
Okay. I will get with Ty and Tony, and then have Tony reach out to Skanska and get it on the board.
Awesome. You're
Sounds
the best,
good. I
man.
will let Sam be aware.